solemn gathering. Assembly and Poznań University of Technology Science Day. Our presence here confirms that science knows no bounds and that cooperation within the UNIS Alliance forms the foundation of modern higher education. At the outset of today's meeting, I would like to invite Vice Rector for Research at Poznań University of Technology, Professor Wojciech Sumelka, to take the floor.
Ladies and gentlemen, first of all, thank you very much for being today with us. Maybe a few words about the idea of Science Day. So, as a Vice Rector of Science, I noticed that in PUT, well, we are very brilliant, but sometimes we should cooperate more, as nowadays problems are interdisciplinary and it's not possible to solve them only, within a small single discipline. So we started PUT Days, Science Days, 4 years ago. And today, being a part of European University, we decided that we could, in fact, do more because the potential of EUNICE, our European university, is 10 times bigger compared to PUT. So I hope that you will enjoy brilliant lectures, brilliant plenary lectures. We have also some workshops which are in parallel to this room, so I hope that you will also enjoy it. But maybe the most important part, it will be discussions during lunch breaks and coffee breaks, so please enjoy all part of this event. One more time, thank you very much for your attention today. Thank you.
Thank you. Now I would like to give the floor to the host of today's event, His Magnificence Rector of Poznań University of Technology, Professor Teofil Jesionowski.
Good morning, ladies and gentlemen. Dzień dobry. It is really privileged to welcome all of you at our university. It's mean Poznań University of Technology. Distinguished rectors, presidents, members of advisory boards, dear colleagues, students, and associated partners, dear members of the UNIS community, dear friends. I'm very happy to see you in such good spring mood. Today it is raining, but let me say spring mood is fantastic, I guess, in Poznań, where the Polish state was founded at the university with over a century of the tradition, Poznań University of Technology, where a UNIS, European University for Customized Education, was, let me say, launched in 2019, and we received approval from the European Commission in 2020. So we are proud that the UNIS was established here, that the state of Poland, which is very, very important for us. We are really proud of this. Since then, we have successfully building of UNIS family with 10 universities and numerous affiliations, universities and institutions. I hope that this initiative will develop the spirit and solidarity. So it is here in Poznań that we commemorate the 5th anniversary of the June 1956. It was, let me say, Solidarity Uprising. It is close to this university. So it's very, very fundamental for the Solidarity was born here, and after that was also born in Gdańsk, very famous. So we are proud of this. Many of victims belongs also to this university. And because of this time, the Great Poland uprising in 1990 was also established, that the state of Poland was born. And one that we are proud today is the members that the Poland is real, I guess, not only real, but the important member of the European Union. So we are also extremely proud of this. Please accept my best wishes and all the best to all of you, all of, let me say, fantastic and renowned institution, as well UNIS member. Let me also personally welcome the former president of the European Academy of Science, Rodrigo Martins. We met together, let me say, 6 years ago, to establish fantastic, let me say, Center for Material Science. So I hope that today's Science Day, as Wojciech Sumelka mentioned, will be also inspiration for common success of European Union, common success for UNIS, and common success for all members of UNIS family. Enjoy the stay in Poznań. Thank you.
Open, modern and dynamic. highest level. But above all, the university is about people and their everyday experience. From the dynamic Konkolevo campus with its aviation hangars to the green Varta campus, we continuously invest in modern student dormitories, a unique sports centre for people with disabilities, and relaxation zones that allow students to recharge between classes. The safety of our community is ensured by the newly established Academic Guard. We combine the energy of development with professional excellence. Poznan University of Technology, responding to the challenges of the modern world by creating a better future. Poznan University of Technology.
Modern and open university. This is a short, summarized take of our university in the form of a short film. Let me now ask our esteemed guests to address us. I would like to invite Professor Wolfram Berger, Vice President for Internationalization, Brandenburg University of Technology, Cottbus-Seftenberg.
Dear colleagues and friends, very pleased again to address you today here at the Boston University of Technology at this UNIS GA, also on behalf of my university's president, Professor Gesine Gander, who can't be with us today. So it's always a real pleasure to see so many familiar faces and again to feel the collaborative and positive spirit of UNIS that always defines the meetings we have. It's also really great, and I think we will see it again in these next coming days, how naturally and easily people from different institutions get together, cross institutional boundaries and also cross country boundaries boundaries in a way to work together. And this openness is exactly what we need, and this openness really creates opportunities, not only opportunities to connect, but probably even more importantly, opportunities to create something really meaningful together. So in other words, to go a step further to create something impactful. And if you look at sort of the main dimensions of what universities do, teaching and research, if you look at teaching, I'm absolutely convinced that UNIS has been creating and can create, make offers that are truly distinct, that go far beyond what we can achieve individually. We know that we can offer innovative, flexible, and most importantly, joint learning opportunities to students. And doing this, we create something that we can't do alone. We also know, we are well aware that there's still a bit of the way to go, so we are not there yet, but really we are progressing well and offering students unique opportunities. And the same applies to research as well. If you look at research, if you look at the 10 different universities, if you look at the research profiles, we really have a strong mix of complementary expertise. And UNIS can serve as a platform to connect ideas, to connect people, and achieve impact together. And I think impact is really the key word and the key aspect of what we are striving to do currently and what we will be striving to do in the future. And I believe if you look at what we are doing, and if you ask yourself what's the key to success, probably the key to success is the energy that all of you bring to UNIS, the energy that we see in all the working groups, the energy that we see in all the meetings, and this joint spirit, shared spirit to transform, to turn ideas into concrete action. I think this is what we need, and this is what we really also need in the next 2 years and beyond that, to lift and to raise our collaboration to the next level. Let me conclude first by thanking all of you who are here, who collaborate with us, who dedicate their time and resources and spirit to UNIS. Thank you for your commitment, thank you for your enthusiasm, thank you for working for UNIS and making us all progress. And lastly, a very big thank you to the university, to Poznan University, to all those who are involved in organizing this GA, to all these visible and also invisible little helpers who will make the GA a success, and last but not least to its rector for offering us such a warm welcome here. I wish you very productive GA. not only productive, but also a very enjoyable GA. So enjoy the next 2 days at the GA and the Science Day. Thank you very much.
Thank you. Now I would like to invite Professor Eftalia Hatsiani, Vice Rector of Administrative Affairs, International Relations and Outreach, University of the Peloponnese.
Hello, good morning. First of all, I would like to sincerely thank our hosts here. Poznan University always gives us a very, very warm welcome, so thank you again, thank you all. And of course, I would like to thank all the members of our UNIS family. It's always so good to see you all. And I'm so looking forward to spending the following days with you all. Thank you. So as you may or may not know, the University of the Peloponnese has a new interim rector. Our previous rector, who was part of, of all this initiative in the beginning, he left the UNIS community at the University of the Peloponnese because he just taken over a new position as the head of the Hellenic Statistic Authority. So here I would like to read to you a message from our interim rector, Professor Sofia Zigas, who couldn't be here with us today. So this is a message from her, and from all of us at the University of the Peloponnese. So distinguished rectors, vice rectors, esteemed colleagues, dear students and members of the UNIS community, it is a true honor for me to address this General Assembly and to be among such dedicated partners who share a common vision and for the future of European higher education. Over the years, UNIS has demonstrated how meaningful collaboration between universities can create opportunities that extend far beyond national borders. Through its initiatives, partnerships, and academic exchanges, the Alliance has cultivated a spirit of openness, innovation, and mutual support that serves as an example for European university cooperation. Our university regards UNIS as an extension of its own academic family, and we remain committed to being a proud member and active contributor to the Alliance's continued progress and development. We deeply value the trust, cooperation, and shared ambitions that unite all partner institutions within this network. Sorry, I'm not wearing my glasses, but still I'm trying to make sense. I should have printed this before. I'm sorry. And even though I know the glasses are on my head, I prefer to be like this. So thank you. At the same time, it is important that UNIS continues to evolve and adapt to emerging challenges. The landscape of higher education is changing rapidly, shaped by technological transformation, societal expectations, and the need for greater international collaboration. In this evolving environment, alliances such as UNIS play an increasingly important role in strengthening academic excellence, fostering innovation, and promoting European values. I remain confident, we all remain confident in the family of the University of the Peloponnese, that the seeds planted during the previous years will continue to blossom into a strong and fruitful collaboration. The achievements accomplished so far provide a solid foundation upon which even more ambitious initiatives and partnerships can be built in the years ahead. Allow me to congratulate all members of the Alliance for their dedication and achievements. I wish you all productive discussions and continued success in advancing the vision and mission of UNIS. Thank you. Thank you all.
Thank you very much. And now I would like to invite Professor José Costa, President, Politechniki Institute of Visual.
Dzień dobry. It's okay now. Good morning. Yeah, today, very early, I walked in Poznan. Fantastic. Congratulations, Poznan. The first of all, I think call you big. I send you a big hug from Portugal. Portugal is a fantastic country, and from Portugal we send you a warm embrace. Over the years, we have felt the affection and the care with which you have helped us grow. We are happy to be part of this family. We must, however, continue to work to strengthen the bonds that unite us. Only in this way can we achieve new success for our people and our country. Europe needs our energy and our vision. The challenges are many, but a united family with clear goals overcomes them more easily. Thank you.
Thank you. Now I would like to invite Professor Philippe Dubois, Rector, University of Mons.
Good morning, everyone. Dear colleagues, dear students, dear friends of UNIS, as I used to say, EU-NICE, University Alliance. Be sure that this is with a given emotion that I'm taking this floor as the last time as Rector of University of Mons in the frame of this alliance. Indeed, the future Rector of Mons is right in front of me. Laurent, can you stand up, please? And then, after the great vacations, well-deserved for each of us, he will take over and will represent our university, and I'm sure that his involvement, our involvement at University of Mons, will be as strong as it is today, no doubt. So I said some emotions, that's true, and two expressions come to my mind now. It's first, science without borders, and the second one is time is flying fast, fast like an arrow. Science without border, as you said, Théophile, we are here 15 universities represented, 10 European universities, direct partners, plus 3 associate universities, plus 2 universities outside the border of Europe, Morocco, Brazil. And we have among us the president of an Academy of Science. And today this is Science Day of UNIS. If this is not the clear proof that science has no border at university are for sure the remaining key for keeping these borders out, I don't see what we are looking for else. Again, fast, time is flying fast. When I see this room, I can recognize many faces that were already present at the beginning, but more and more new faces, which is good, of course. It's very good. But I remember the time with Théophile, with you, Sébastien, and Hakim, when we first started thinking about the possibility of a potential alliance that finally was called UNIS. And today we are here. And so behind the emotion, be sure that I'm very proud as well. And goodwill to UNIS, goodwill to all of you, all of us, and have a nice meeting. And that's the final occasion for me for thanking all our partners. Thank you very much, guys. We are really a big family, and thanking for our host today. Thank you.
Thank you. I would now like to invite Professor Sébastien Grondel, Vice President for Europe and UNIS, Politechniki University of Hauts-de-France.
Dear colleague, dear family, I'm very happy to be in front of you again. Today I have to represent our president of ISBL, who was very disappointed not to be here today, but of course is in spirit with us today. He's asked me to say some words for you, and maybe the first words that come are the following. It makes 6 years that we began this wonderful experience. 6 years that all the team worked together. So first of all, I would like to thank all the team who are here together, because you make really a great job, wonderful job. Each week, when I see all what you have made, online courses, blended intensive program, joint lab, summer school, and of course, you don't forget to have a drink also at all the meeting. All the jobs that we have done has been already presented 1 month ago in front of the European Commission. It was the midterm report. And what says the European Commission? The European Commission says that, okay, that we are on the good way, right way, that we make so many efforts, but that we have also to face in the future new challenges. We have to accelerate. We have to reinforce the ISBL, and that's why it's a pleasure, like you say, Philippe, to have today, of course, the associate partner who will help us to reinforce the ISBL, but also the advisory board for the first time in order to improve our quality. Of course, we have to think to go faster on joint program, on European label, and to go to joint diploma. We have also to think about the science, but you explained that already, Philippe, and I agree with you that it was a pleasure for me to see that this year we deposit many projects. Today, I have also 2 good news for you. One is the Hotel project that will be present in front of the rector. The Hotel project is a project that is developed by UPHF and also by University Catholic of Lille. And the idea is to help our institution in UNIS to develop research and academic cooperation. So this will be a starter. This is the first good news. The second good news is that we will organize in Valenciennes, the 18 and 19 November, a UNIS Synergy Congress. What is this UNIS Synergy Congress? It is the same idea as the General Assembly, but in comparison with the General Assembly, we will put at the same time not only the academic partner, but also the regional institution. And this is something that we have in mind. We want to expand UNIS. We want to make bonding for UNIS. I'm also happy to see that now, regularly, we have the Vice Rector of Research, Vice Rector of Education, which demonstrate the strength of UNIS, because it's not only small team, but it is also all the governance of each university who participate to this event. Last, not least, I want to thank Poznan, really Poznan, for all the effort, and thank you, Théophile, all the effort you have made in order to organize this event. because this is the first time I'm not able to manage the program. I mean, there are so many meetings with series in order to prepare the next project, with the Vice Rector of Research, with the Vice Rector of Education, with the Board of Rector, and with all the teams, so all the work package. So I'm really confusing because it's amazing all the jobs you have made. Thank you, Magda. Thank you, Natalie, for the great job. And enjoy the 3 days in Poznan because we have a great chance to be here. Thank you.
Thank you. Now let me invite Professor Youssef Habibi, Director of the Center for Research on Sustainable Materials, University Mohammed VI Polytechnic.
Thank you. Distinguished rectors, dear presidents, and representative of UNIS universities, and honored guests, student and professor here. It is a profound honor to stand here before this General Assembly on behalf of Dr. Hisham Labti, the president of Mohammed VI Polytechnic University in Morocco, and to bring with me the warm regards of the entire academic community of Morocco, and by extension of Africa. UMCSP was founded as a conviction that higher education and research must be deeply rooted in the realities of our continent, yet radically open to the world. We are an institution built in Africa, for Africa, but with the strong belief that the great challenges of our time, whatever in climate, food security, critical materials, or human development, demand partnerships that transcends border and bridge continents. Knowledge, as Philip said, science or knowledge in general is without border. And UNIS is a material representation of this. UNIS reflects indeed precisely our spirit at UMCSP, a network of universities united not merely by geography, but by a shared ambition to reimagine what not European, but universal university can be in the 21st century. Inclusive, interdisciplinary, and internationally engaged. We see, as UMCSP, we see in this alliance a natural partner for our mission. Our campuses host research infrastructure of continental and global relevance, and our students, our faculties are eager collaborators, ready to bring a distinct African perspective to the joint programs, whatever they are, research initiative, and the broader conversation about the future of higher education. We are proud to be an associate partner of UNIS Alliance and sharing its common vision. We came here to Poznan not as an observer, but as a committed partner, already engaged only after 2 years of being partner, engaged in to contribute, to learn, and to build together something greater than any of us could achieve alone. On behalf of the President Hisham Labti, I wish this General Assembly every success in its deliberation. We look forward for the future of a shared vision, our mission toward excellence and enduring friendship. Thank you for Poznan Technical University for all the warm welcome, and thank you all, and looking forward for exciting discussion these 2 days. Thank you.
Thank you. I would now like to invite Maja Maćkowiak, ISAP student, Poznan University of Technology.
distinguished rectors, esteemed academics, partners, guests, and fellow students. Today, I have the pleasure to speak to you on behalf of the UNI Student Advisory Board. As students, we experience international cooperation through courses, mobilities, and most importantly, through the communities that we build. This model of student involvement is becoming increasingly common in European university alliances. But what makes UNIS truly unique is that it gives students not only access to international opportunities, but also a seat at the table. And we are very happy to be a constant part of the discussions and support the development of a more inclusive and student-centered European university. I hope the coming days will be a valuable time for productive discussions and stronger collaboration across our alliance. Thank you for your commitment to this partnership, and most importantly, thank you for trusting us to play an active role in shaping it. I wish us all a successful General Assembly and a productive Science Day, and I look forward to the discussions ahead. Thank you.
Thank you. Let me now invite Professor Gabriel Moncalian, Vice Rector for University Transformation, University of Cantabria.
Thank you very much. Good morning and welcome. Hello to everybody. Thank you very much, Rector Theophil. Thank you very much, colleague rectors, colleague scientists, colleague students. Thank you to everybody for your invitation for being here today. So on behalf of my rector, Professor Conchi Lopez, who unfortunately cannot be here today, this is what I like to say at the beginning is, well, we are very grateful, we are very happy to be here, as you were saying before, in the seat of this wonderful alliance. We have been working together for more than 5 years now, and we consider ourselves friends, family, as it was said before. So today, it is the beginning of this assembly, where according to the agenda, we are going to be focused on our three pillars three pillars of our alliance: teaching and academic offer, European values, of course, and research and knowledge transfer. I was told to talk today about how to accelerate research and knowledge transfer, and this is what I am going to do. So in the Alliance, we have already started working on different activities. Of course, in our 10 universities, we have several research groups. I was thinking today that maybe we have close to 1,000 research groups. That, of course, we do a very good, very nice research alone and in collaboration with some other universities. But one thing that we have to start doing now is collaborating between each other. We have already started doing some activities, such as the joint research portal, to put together some research facilities and infrastructures. We have been doing also some workshops, of course. This Science Day, it could be a good example of the research that we are doing together. We are also going to have the synergy workshop that Sebastian mentioned before. But I would like today to talk about the young researchers, the young students, that it is one of the focus, one of the goals of our alliance. Regarding young students, we have to think on them. We have to do activities for them. And one of the activities that we have already started is the internship portal. At the beginning, Christina knows it very well, we thought about doing an internship portal mainly thinking on companies. But then we have transformed this portal into an internship portal for companies, but also for research groups. So I think that it is a good opportunity for our PhD students, but not only PhD students, but also graduate students or master degree students to find an opportunity to go abroad, to go to one of our other universities, or even to our associated partner universities to do some internship during the summer or during the academic year. So this is one of the main things that we are going to do to help our students and to help our research group to improve their science activities. The other pillar of our alliance are the excellence programs. So there is an excellence program, or there is a kind of excellence programs where we mix academic offer and research, and these are the PhD programs. We cannot forget about the PhD students, about the joint PhD degree programs, where we talk about science. So, as I said, we are doing very good research. We are doing very good articles and projects alone and in collaboration with some other universities. But there are some research activities that it is much better if we do it in company or in the alliance than alone. And one of them are the multidisciplinary new research projects or new joint degrees, such as the Global Health Program. We are already working on this kind of programs where we are going to mix not only human health, that is very important, but also some other research topics such as veterinary sciences, nursery, environmental sciences, and so on. So it is easy to understand that we should do it together instead of alone, because we know, probably some of the groups know a lot about veterinary sciences, but not about human health and so on. So let's do it together, let's keep collaborating, and let's improve research together. Finally, I would like to thank again Theophil, Marius, Marta, all the people of this university. We are proud to be because we're very happy to be, because as you said before, this is the seed of the alliance. So we are really at home with our friends and family. And I would also like to thank our ASBL General Secretary, and also Magda, and also Natalie, for your help in the organization of this event. So thank you very much, and let's do research, and let's do research together. Thank you.
Thank you. Now let me invite Professor Anna Moniuszko-Malinowska, Vice Dean for Science and Evaluation, Medical University of Białystok.
Dear rectors, dear all distinguished guests, dear organizers, as the representative of the Medical University in Białystok, Poland, I would like to express that our university is being privileged to have opportunity to being the associated partner of UNIS. Our travel started in 2023, however, it speeded up in 2025, thankful to the great, wonderful support of Poznań University of Technology and our joint success in getting funds from the National Agency for International Exchange in Value project. Thankful to these activities, we already started the scientific and also didactic cooperation with University of Cantabria, University of Catania, University of Mons, of Peloponnese, and also University of Viseu. However, we still have the area for wider and stronger collaboration. So I hope that this 2 days assembly will be the opportunity to make it happen. Thank you.
Thank you. Now let me invite Professor Jirker Moodysson, Vice Chancellor, Karlstad University.
Good morning, everyone, and thank you for having us. I think a lot of good things have been said already, so in respect of time, I will not repeat everything, but I will agree with what has been said. And on behalf of Karlstad University, I want to express my sincere appreciation to the organizers, Poznań University of Technology, and to the entire UNIS community for coming here, contributing. As you know, the core of UNIS is education, customers education, where we combine our strength areas, providing an even better offer together. But as you also, all of you know, higher education must be anchored in research. Therefore, I think it is a great initiative to combine this General Assembly with Poznań University Technology's Science Day. While education may be planned and designed in collaboration, research is much harder to design in terms of collaboration. So therefore, I think it makes good sense to do this now a number of years into the UNIS collaboration when we have sort of started to build our a range of sub-alliances within the large alliance. Now, to see what will come out of this, I think that we don't know that yet. And I think that UNIS, as a community for education, joint efforts in education, may serve as a catalyst for further alliances in research. So I'm very much looking forward to the coming days and see what comes out of it. So again, thank you very much for inviting us, and I wish you all a couple of fruitful days. Thank you.
Thank you. Now let me invite Professor Maria Alessandra de Ragusa, Vice Rector for Internationalization of Education, University of Catania.
Good morning, colleagues, students, friends. First of all, I wish to thank Theophil and Marius for the effort in this perfect organization and warm atmosphere. So now I say you hello from the rector of University of Catania, Professor Enrico Foti, that is not here, but is represented very well from the Deputy Rector of Education, Professor Giuseppe Speciale, and Deputy Rector of Internationalization of Research, Professor Giuseppe Spoto. Also, I wish to personally express you my gratitude for this invitation here, because for University of Catania is a very well-known Poznan University. We have an emeritus professor in Catania that founded his career mainly in strict collaboration with members of this university. So I'm looking forward to come back home and describe him or this visit in the city and the university. And concerning UNIS, I think that is an extraordinary opportunity for collaboration. Indeed, very recent, a president of a degree course asked me to do to evaluate the possibility of a double degree with another university. And we'll see and individuate a university of the Alliance as a possibility of this double degree. So this president of degree course was in the city of the University of the Alliance, and it is a work in progress to do this double degree course. So thank you for UNIS and long life to UNIS. Thank you to all of you.
Thank you. Now let me invite Professor Tania Rizikoko, Vice Rector of Education and Stakeholder Relations, University of Vaasa.
Rectors, dear friends, first of all, I want to express our thanks to the Poznan University of Technology for hosting us in this beautiful and inspiring surroundings. Many thanks to all the people who have contributed to this event in the Poznan University of Technology and also in the UNIS AISBL office. I also want to send greetings from the Rector of University of Vaasa, Professor Minna Martikainen. Dear friends, knowledge and research, as already talked here today, is crucially important to the future in Europe and in the whole world. It is also important in the upcoming European University Alliance period, even though alliances are primarily education-oriented instruments. In our university in EUNIS, we conduct a wealth of high-quality research, such as PUT's highly ranked research in engineering and technology, or in our own university research in business and business administration. Excellence and impact. The UNIS universities are also very closely connected to the industries, which enhances our societal impact, so we really can make an impact. Through our high-level research intertwined with industry, UNIS can support European or Europe's key priorities in developing growth, green transition, digital transition, energy transition, security and resilience, as well as technological autonomy. In the global competition, we need to be faster in all of these transformations, transforming the research into growth and development and well-being. And from the industry's point of view, one of the key questions is also how fast the organizations, the companies are able to use the artificial intelligence. And here again, the universities, and especially the universities like ours, have a possibility to take a bigger role. As already mentioned, the traditional mutual research collaboration in UNIS is rather young. It's taken its shape, and hence we have all the opportunities to make it flourish. We already have demonstrated good successes, for example, in launching a Marie Skłodowska-Curie Action doctoral network. So we consider, and I consider, it is important to make more openings, more initiatives of this kind, and to offer opportunities for young researchers, especially for young researchers, since the young talents, they are the ones who make the future. Thank you.
Thank you. Let me now invite Patrick Scoffler, President, Catholic University of Lille.
Hello, everybody. Lille Catholic University is the more important private non-for-profit university in France. It has been created more than 150 years ago, rooted in the Catholic humanist tradition. It nowadays represents about 40,000 students and a very wide range of academic fields, from engineering to business, from medicine and health to law and social politics. We are very proud of being part, as an associate member, being part of UNIS, because in Lille we are very open to Europe, and Lille Catholic University has been for a long time a promoter of European construction. So this recognition as an associate member was supported by the University Politechniki of Hauts-de-France, with which we have a strategic partnership for a long-term strategic partnership. I would like to thank you for accepting our application and tell you that we are very keen to take our part, to participate to common projects, to common efforts in the fields of education and research. I would like also to thank the Poznan Technology University for hosting this event. All the best for you.
Thank you. Now let me invite Professor Demetrius David da Silva, Rector, Federal University of Viçosa.
Good morning to all distinguished rectors, vice-rectors, colleagues, partners, students. It's a great honor for the Federal University of Viçosa, UFV, to join the Eunice Alliance as an associated partner. UFV is a public, tuition-free Brazilian university that is celebrating its 100th anniversary this year. Originally created with a strong focus on agriculture and veterinary sciences, UFV has grown into a comprehensive and research-intensive institution, recognized today as one of the leading universities in Brazil and Latin America. We currently have around 19,000 students, 1,300 faculty members, and 54 postgraduate programs across a broad range of fields. For UFV, joining Eunice means becoming part of a shared vision of higher education based on cooperation, innovation, sustainability, and intercultural dialogue. Our path toward Eunice began through the University of Catania, with whom we have developed a very fruitful cooperation, including a joint PhD initiative and academic exchange involving students and researchers from both institutions. We are also strengthening collaboration with the Politechniki Institute of Viseu through 2 Erasmus Plus project proposals. One focuses on the intergenerational learning and social inclusion, while the other is dedicated to innovative education, agroecology, and sustainable food systems. In addition, UFV is already contributing to the Eunice educational ecosystem by offering online courses to the Eunice course catalog for 2026-2027. UFV joins Eunice with enthusiasm, believing that today's global challenges can only be addressed through strong international cooperation and shared perspectives. Thank you so much.
Thank you. And now I would like to invite Dr. Hannu Vahtera, Rector, Vasa University of Applied Sciences. Apparently, Dr. Vahtera is not with us. Okay, so thank you very much indeed for providing us with these very kind and thought-provoking words. And let me move on. Let me now give the floor to President of the Board of Directors, Vice Director for International Relations at Poznań University of Technology, Professor Mariusz Głąbowski, who will talk about programs supporting research and academic cooperation.
Ladies and gentlemen, dear friends, first of all, thank you very much. So many words addressed Poznań Technology, warm words. And following your inspiring speeches, I would like to thank for highlighting the crucial role of science and education, but science as a foundation for our cooperation and development. Today's event, combining the UNI's General Assembly with the Science Day of Poznań University of Technology, offers an excellent opportunity to turn these ideas into concrete actions. I would like to encourage all of you to actively build within UNI's alliance international research teams, develop joint study programs, and co-create courses. To support these ideas, to support these efforts, I strongly recommend making use of the UNI's For You project funds, as well as the resources obtained by Poznań University of Technology for our common needs, UNI's needs, from National Agency for Academic Exchange, which enable us to host meetings of such teams here in Poznań and provide financial support for joint publication. I suppose that in the next slide, you can see the basic information about the programs that are available. But first of all, please contact the office, Marta Malepszak, and he will help all of us in giving information how we can apply for funds, helping us in networking here in Poznań, focus on build research teams, build common educational programs, and first of all, also to support us with financial support in order to cover the cost of open access of our joint publications. And finally, to capture this important moment of our collaboration, I would like to invite you all to take the group family photo. So I kindly ask you, rectors, distinguished representatives of partner universities, to step down from the stage and take places in front row of the auditorium in front of the audience. So thank you very much.
So before we begin, can I ask all the people actually sitting here on my right and on my left, actually, and to come a bit to the middle so everybody's going to be in a photo? Okay, and can you please now remain, can you stand up and remain in that position for the duration of taking a photograph? Okay, so all the people actually, can I just ask you to come to the middle of the room so that everybody can be in the photograph? Won't take long, thank you. And maybe, so we have a group of students over there. Can you just move a little bit to the center of the room? Because I'm afraid actually you won't be in the photograph. Okay, there's still plenty of space in the middle. Thank you.
Thank you.
Thank you very much indeed, right. We've got hundreds of photographs now. So ladies and gentlemen, before we proceed to the next stage of today's meeting, there's going to be a short break now, a technical break to take. Ladies and gentlemen, continuing in the spirit of inspiration, we now begin the substantial part of today's meeting, the substantial part of Science Day. Before we begin, I would like to take a moment now and I would like to invite you to explore projects that have already been shaping the reality of tomorrow. And before we commence, I would like to inform you about the rules concerning the amount of time that is going to be allocated for each presentation. Each presentation is given maximum 35 minutes to deliver, and the time will be measured by a clock visible both to the presenters and to the audience. I'm going to ask, in turn, particular deans from Poznań University of Technology and their guests. So let's start. I would like to invite the Vice Dean of the Faculty of Civil and Transport Engineering, Professor Zdzisław Pawlak, and his guest from the University of the Peloponnese, Professor Maria Giovanna Pastore Carbone, who will join us online.
Ladies and gentlemen, distinguished guests, it's my pleasure to introduce our first invited speaker, Professor Maria Giovanna Pastore Carbone, Assistant Professor at the Department of Mechanical Engineering of the University of the Peloponnese in Patras, Greece. She received her university degree in materials engineering and her doctoral degree in Materials and Structures Engineering from the Department of Chemical, Materials and Production Engineering at the University of Naples, Federico II in Italy. She has also gained significant international research experience as a postdoctoral researcher at the Institute of Chemical Engineering Science of the Foundation for Research and Technology, Hellas, as well as at the Department of Chemical Engineering of the University of Patras. Her research follows a multidisciplinary approach to the design, production, and characterization of advanced materials, mainly nanocomposites, with specific functional and structural properties. Her work combines materials science, physics, chemistry, and nanotechnology. Professor Carbone has co-authored 36 scientific papers in international journals, 3 book chapters, and 6 patents. She has also actively participated in more than 50 international conferences. Her current research focuses on the integration of graphene and related materials for the development of multifunctional systems, including lightweight composites for electromagnetic interference shielding, protective coatings against ultraviolet and visible radiation, coatings against gas and vapor formation, and sustainable composites enhanced with graphene and other two-dimensional materials. By combining concepts from materials science, physics, chemistry, and nanotechnology, her research addresses several applications for potential impact on future society, including high-performance nanocomposites, sustainable composites materials, preservation of cultural heritage, sensitive sensors, and actuators. The title of Professor' lecture today is Graphene and Beyond, from nanoscience to transformative macro-scale applications. Professor Carbon, we are very pleased and honored to welcome you to this conference at Poznań University of Technology. The floor is yours.
Thank you very much for the kind presentation. Good morning everyone, and thank you for the invitation to the Science Day. I am Maria Giovanna Pastore Carbone from the University of the Peloponnese. Unfortunately, I could not travel due to health issues, but I am pleased to join the conference remotely and present my work to you today, even with a hoarse voice. And please also excuse me in advance if I may cough during my talk. Well, before starting the scientific part, let me briefly introduce where I'm speaking from. Here is Poznan, where the Science Day is being held at the moment, and where I wish I could be with you today. And here is Greece and its capital, Athens. The Peloponnese is this peninsula and geographic region in the southern Greece, where I'm currently speaking from. In this region, the University of the Peloponnese has the academic departments distributed across these 6 pinned cities. And the Polytechnic School is located in Patras, and I'm currently affiliated as assistant professor in synthesis and mechanical behavior of nanomaterials at the Department of Mechanical Engineering. Well, as a materials engineer, we know that through human history, the progress of civilization has been strongly connected to the materials we were able to discover, to engineer, to use, from the Stone Age to the Bronze Age, the Iron Age, and eventually the Silicon Age. At the same time, nature itself builds matter in 3 dimensions with length, width, and height, which define the world around us. However, in the last decades, a new class of materials has emerged and has attracted enormous scientific interest. They are the so-called 2-dimensional materials, or 2D materials. These atomically thin systems open the door to entirely new physical phenomena and technological possibilities, and lead to what many call the 2D materials revolution. Well, let's understand now what a 2D material is. Let's take a deck of cards and cut it several times until we hold only one card. The card in our hand will have a length, a width, and virtually has no height. Well, some materials with a layered structure resemble this deck of cards. And when we extract one layer, we obtain 2D materials. Graphite, which is one of the most abundant materials on Earth, possesses this layered structure, and each layer consists of carbon atoms arranged in a honeycomb lattice. And if we extract one layer from graphite, we obtain graphene, the atomic thin material, which was firstly isolated approximately 20 years ago by Professor Andrew Geim and Kostya Novoselov, who were honored for this discovery with the Nobel Prize. And graphene, thanks to its wonderful properties, opened the door to an entirely new class of materials. And soon after the discovery of graphene, researchers began exploring many other 2-dimensional materials beyond graphene. Some of them behave as semiconductor, others like conductors, insulators, superconductor, or even magnetic materials. And today, 2D materials are considered highly promising solution for next-gen applications such as flexible electronics, energy storage sensors, membranes for water purification and photonics, and also advanced composites. Well, but let's focus on graphene, which is the 2D materials I've been working since last 10 years. Here is a picture of a graphite specimen. Graphite is known to easily leave marks on paper, and that's why it is the core of a pencil. The structure of graphite is layered, and we can see it in this SEM image of graphite, where we can clearly see all the distinct layers. So graphite makes for a great writing material because of this peculiar layer structure. And well, these layers are weakly bonded to one to the other. So if we stick, let's say, a scotch tape on the surface of graphite, we can be so lucky to detach a layer from the whole layer structure. And that's how graphene was isolated for the first time. This technique, which we adopt in the lab to obtain perfect micrometric graphene flakes, as the one I show in this optical micrograph. And this is what we call a mechanical cleavage method to obtain graphene. But what makes graphene truly unique is that it combines exceptional properties that can be normally found in a single material. Let's start from mechanical properties. Graphene is one of the strongest material ever measured, with a Young modulus close to 1 terapascal and an intrinsic strength which is more than 100 times stronger than steel. And it remains extremely lightweight and flexible. Moving to electrical properties, graphene has outstanding electrical conductivity, which is significantly higher than copper. Then graphene also exhibits extraordinary high thermal conductivity, even higher than diamond. And this means that it can dissipate heat extremely efficiently. Finally, graphene has also very interesting optical and electronic properties. In fact, it is almost transparent and exhibits an extremely high electron mobility. So overall, graphene is not only another just nanomaterial, but it is a platform material with multifunctional properties that can potentially transform many technological sectors, from electronics to energy to aerospace and biomedical engineering. So after more than 20 years from its discovery, graphene can be now produced using different methods, as you can see in the slide. After the scotch tape technique of mechanical exfoliation, other important techniques are the chemical exfoliation, which is a bottom-up technique, where we build graphene from the decomposition, from the exfoliation of graphite using some solvents. And then we shall consider also the chemical vapor deposition, which is a very important technique that allows us to obtain monolayer graphene from the decomposition of gas precursors and metal catalysts. All of these techniques basically yield different types of graphene with different dimensions, different qualities, and of course, different costs. But the most important thing is that now mechanical exfoliation and CVD method are now scalable, okay? So mechanical exfoliation, as told earlier, yields perfect graphene flakes, but these are very, very small. The process is stochastic and yields a limited number of flakes with random shapes and random location of substrate. And therefore, this kind of graphene is generally used for basic research on this material. On the other side, liquid phase exfoliation is now industrial process, and yields graphene in powder, generally multi-layered structures and defective structures with lateral sizes from hundreds of nanometers to less than 10 microns. And this is cheap graphene. Then we have here chemical vapor deposition, which is now does the process and yields monolayer graphene almost perfect in centimeter or even meter size dimension deposited on copper foil. So basically, we now know that graphene is the wonder material, and there are now strategies at our hands to produce it on an industrial scale. But for practical applications, we need to consider something more. Due to its atomic thickness and structure, graphene cannot stand alone in real application without a supporting substrate. So just imagine a veil with the thickness of only one atom to survive in our 3D world. It is not an easy task. So in practical application, graphene occurs in combination with the various substrates to form graphene on substrate systems and composite systems. In my research, we investigate how graphene and related nanomaterials can be integrated into polymer, into plastic matrices to create a lightweight, multifunctional composite with enhanced mechanical, electrical, and other functional properties. Of course, depending on the type of graphene, flake-like or continuous type, we can obtain different systems. For example, if we introduce graphene nanopowder into a plastic matrix by using a solution mixing method or melting mixing via extrusion, we can create nanocomposites. Another route is that we can deposit graphene, continuous graphene layers on a substrate, for instance, on a plexiglass plate to obtain functional coatings. Or we can introduce and embed a continuous graphene layer into different composite architectures, which we now call nanolaminate. So basically, based on the type of graphene which is included in the composite architecture, we can basically classify composite into three types. The discontinuous composite, where graphene is added as tiny flakes, which have random distribution, okay, and orientation in the matrix. This is the most basic nanocomposite configuration we can produce. Then we have the nanolaminates, where we have the alternation of large size graphene layers with layers of polymers. These composite structures, as I will show you later, can be fabricated by using complex techniques which give you control on the nanometric scale for graphene distribution and, of course, orientation. And then there is a third category of graphene polymer composite, this is called hybrid composite, where we can include graphene flakes into fiber reinforced polymers, basically having hybrid systems of graphene with carbon fibers, glass fibers, carbon fibers in a resin. In this talk, I will basically focus on these first two types of composites. So let's start with the analysis of discontinuous graphene composites. Nowadays, excuse me, nowadays it is clear that when adding small graphene flakes to matrices, it is very to translate the full potential of graphene from nano to macro scale. The analysis of the relevant literature in the field has shown that, unfortunately, the performance of graphene composites is pretty inferior compared to the expectation. And unfortunately, this is particularly true for the mechanical properties. In fact, here I show you some typical stress-strain curves for polymers that belong to the three categories: elastomers, thermoplastics, and thermosets. And we can clearly see that the addition of graphene does not always boost the performance of the composite. And what we deduce now is that we have an inconclusive picture. The mechanical properties of this continuous flake-based graphene composite are not generally improved. And this seems to be quite disappointing for a filler which is expected to have an elastic modulus of 1 terapascal and a strength higher than 100 gigapascal. On the other hand, if the addition of graphene is not always accompanied by an important improvement of mechanical properties, well, it boosts other functionalities. In fact, as we can see here, the addition of graphene to an insulate plastic such as PET can promote electron transport and make the nanocomposite electrically conductive. More interestingly, graphene has been found to be really effective in promoting fire retardancy in plastic, and we know that plastic materials are no fireproof. And another interesting property graphene can provide is damping, which is the ability to reduce vibration. And this property is particularly interesting in vehicles and mechanical systems. So at the end of the day, we can say that graphene as nano additive still makes a lot, and even when introduced at small quantities in nanocomposite. But why graphene does not behave as the perfect reinforcing filler? And this is something I've been going through personally in my research and on nanocomposite. And well, the answer is in the mechanics of composites. The theory of composite explains that the mechanical performance of a composite material depends on the capability of stress transfer between the matrix and the filler, which is the fundamental mechanism by which a composite material bears a mechanical load. So when we have an external force, the more compliant matrix deforms and transfer the load to the stiffer filler via shear stresses and the interfaces. And this allows the composite to achieve superior mechanical properties compared to the separated phases. And stress transfer depends on several factors, such as the stiffness and geometry of the reinforcement, the shear properties of the matrix, and the quality of the interface. In this slide, you can see a schematic of the strain profile which develops in a filler embedded into a matrix. And when we have a long filler, a long flake, strain in the center of the inclusion matches the strain of the matrix, which is the applied one. Why, if the flake is too short, like in this case, and unfortunately this is the dominant trend in the case of graphene nanocomposite, strain in the filler is too low, so the performance of the composites from a mechanical point of view does not match the expected one. So a minimum length, critical length, is required so that stress can reach, through shear stresses, its maximum value. And by using Raman spectroscopy, we have determined stress transfer in model graphene polymer nanocomposites, and we have demonstrated that this minimum length is decade of microns, which is something that cannot be easily found when we work with graphene powders in nanocomposites. So here is the real experimentally measured profile of strain developed into graphene as measured by using Raman spectroscopy. I don't want to go into the details of this technique, but I can easily say that basically we can measure stress and strain at the nanoscale in graphene by analyzing the position of specific Raman peaks of graphene, which are found to shift under the imposition of an external load. And what we see here is that in order to fully develop strain, graphene shall have a lateral size of at least 20 microns. And this, unfortunately, is hardly verified in the typical graphene powders available both in the labs from chemical exfoliation and in the market. So basically, when working with discontinuous composites, okay, the traditional ones, we shall have in mind that this kind of graphene show limitation, such as the tiny dimensions reducing stress transfer capability. Then it is difficult to find monolayers. Basically, graphene powders are multi-layer nanoplatelets. And this reduces further the composite reducing efficiency. And we also shall bear in mind that there are defects, wrinkles, several impurities. Other typical issues of discontinuous composites are it's difficult to achieve an homogeneous dispersion, an homogeneous distribution of the filler within the matrix. And so there are agglomeration issues. And also it's quite difficult to reach a strong bonding, and generally this situation can be aided by the use of functional groups and compatibilizers. So based on these limitations, in the last years, we have worked on the development of a new class of composites, which have the possibility to overcome all of the aforementioned critical points of the discontinuous composite. And that gives us the possibility to fully exploit the potential of graphene towards new transformative application. Well, to understand, let's take a bunch of tiny graphene flakes, not perfect though, and we mix them with plastics. So we obtain these discontinuous composites. And we can clearly see that we may reach a random distribution of the filler in the matrix. What if we substitute these tiny flakes with continuous large size monolayer graphene with good quality, which can be synthesized via chemical vapor deposition? And we try to fabricate a new composite where we have this alternation of layers of graphene to layers of polymers. In this case, we obtain this new architecture, which we call nanolaminate. In this case, we expect to overcome the problem of stress transfer because we are dealing with large centimeter size flakes, layers of graphene, and also we have a nanometric control on graphene distribution. So in light of the discussion on lateral size, distribution, orientation, agglomeration issues, if discontinuous composite performs like a Fiat 500, the graphene nanolaminate is expected to be a Ferrari. While in the nanolaminate configuration, the continuous monolayer graphene that we depict here has a thickness of only 0.33 nanometers and is embedded in polymer thin films, which have thicknesses from some hundreds of nanometers to some tenths of nanometers. And by changing the thickness of the polymeric layers, we can vary the volumetric fraction in the final nanolaminate. Well, to fabricate the CVD graphene nanolaminates, we developed a novel fabrication method, which is an iterative lift-off float-on process combined with wet deposition. It is basically an iterative method when we manipulate and combine graphene with ultra-thin polymer films in a multi-layer membrane with a final thickness of 5 to 10 microns. And by opportunely choosing the polymer, we can target a specific application. For instance, we fabricated PMMA graphene nanolaminates for EMI shielding application, and also we fabricated graphene polyethylamide nanolaminates to serve as flexible heating element. Well, as expected, the incorporation of large-size CVD graphene offers, excuse me, large lateral size for efficient stress transfer and a uniform and controllable dispersion in the matrix. And here I show you the amazing results we obtain in terms of stress strain curve for the PMMA graphene nanolaminates. And we can see that the incorporation of a very, very small amount of CVD graphene, we can see up to 0.5% graphene, can boost significantly stiffness and strength. And if we plot the elastic modulus of the nanolaminates as function of graphene content, what we can see is that for 0.5% of graphene, we can achieve a 3-fold increase of elastic modulus, which is an unprecedented result in the field. In fact, if we compare our results with typical discontinuous composite obtained with few layers graphene flakes on which geoflakes, we can clearly understand that we can get what we can get with CVD graphene nanolaminates with an effective modulus which is quite close to 1 terapascal, which is what has been measured on perfect graphene. And nanolaminates are electrically conductive as well, and they show a non-percolative conduction mechanism and show the highest conductive values ever reported for polymer field with graphene-related materials in short dimensions. And we investigated further the performance of the nanolaminates in order to develop advanced solution for next-gen application, and in particular with in collaboration with FORTH, which is the largest research center in Europe, and with the University of Napoli, Federico II. Napoli is my hometown. We have investigated the EMI shielding behavior of this material. Basically, the interference of electromagnetic devices is nowadays a critical issue, as we have electronics everywhere. So it is important to have barriers and to produce barriers to attenuate the electromagnetic wave and to reduce interference problems. And what we have observed is that the nanolaminates as thin as 5 microns membranes can help in attenuating the electromagnetic wave of terahertz frequency by more than 99%. And this is a fantastic result. And we've also found that graphene nanolaminates show the highest EMI shielding effectiveness per unit of thickness and weight. even reported for synthetic materials in the terahertz frequency range. And these results, of course, have a huge impact on communication technologies. Then we built nanolaminates, substituting the engineering plastic matrix like plexiglass with high performance. Polymers such as polyethyramide. Polyethyramide is a plastic that withstand high temperature, and in light of the high electrical conductivity of these nanolaminates, we investigated the classical Joule heating phenomenon, which is basically the phenomenon where electric current passing through a conductive material converts electrical energy into thermal energy. And as we can see here, this membrane show impressive Joule heating efficiency with very quick response and low power consumption. These thin membranes, as we can see here, are also flexible and are capable to retain their Joule heating even when bent, and in a stable way. So it is clear that we can also adopt these new materials as flexible heaters. And flexible heaters are nowadays adopted in wearable medical devices, but also in aerospace. And for instance, talking about airspace, airplanes have huge problems with ice forming on their wings. Okay, and what we did, we carried out a proof of concept de-icing experiment, and as we can see from these pictures, we have covered the nanolaminate with a bunch of ice, and when the nanolaminate is switched on, the ice melts in less than 1 minute. And this experiment demonstrates the perspective of graphene pay nanolaminates as heating elements for the icing application. And that's not all. Nanolaminates also show impressive thermal conductivity and gas barrier properties. And basically, these are other researchers conducted in collaboration with the Max Planck Institute and again, University of Napoli, Federico II. And we can see again the potential of these materials enriching effective properties and possible application, for example, in the case of thermal management and also gas barrier. So to conclude, graphene-based polymer composites offer enormous potential for next generation application of multifunctional materials. But what have we learned from this journey? Graphene is the perfect candidate as filler in nanocomposite. However, careful shall be taken in the design of the composite. In fact, if we choose graphene in micrometric powder form, we can just expect a moderate improvement of mechanical properties, if any. On the other side, we can achieve multifunctionality, and also this discontinuous process composites can be produced on industrial scale at affordable cost and can make graphene enter in consumer products. If we target high-end application, we can think of using the nanolaminate configuration that allow us to exploit the full potential of graphene. However, although CVD graphene can already be produced industrially as continuous meter-long rolls on copper foil, the scalability of the overall process for producing laminate is still a major challenge, and for this reason we are currently developing new fabrication lamination routes for integrating thin polymer films with graphene, and developing reliable and industrially viable fabrication routes will be crucial for translating the extraordinary properties of graphene from the laboratory to real world application. So I would like to acknowledge EC for funding this research activity, and several research groups and several colleagues of mine with which have been working on the development and characterization of laminates. Professor Kosarialiotis from 4th RIS, Professor Anastasio Manigas from University of Patras, Professor Antonello Andreone and Giuseppe Menzitieri from the University of Napoli, Dr. Nikos Koutroumanis from Madrid, and Dr. Christos Pavlou from Delft, Netherlands. And I would like to thank you again, all the organizers, for the invitation and for making possible for me to join remotely today. And of course, thank you all for your attention. And I will be happy to take any question for you. And thank you again. I hope I was in time with my co-talk. Thank you.
Professor Carbone, thank you very much indeed for a very informative presentation on a very interesting topic. So we haven't got much time, but maybe there are some kind of questions that somebody from the audience would like to ask. We've got a mic here, so... Oh, yes, there's a gentleman over there, so...
Thank you very much for this. Yeah, thank you very much for this very nice talk and very inspiring talk. So you have shown that you can not only work on the thickness of the nanolayers, but also on their stiffness, and you are now able to change the stiffness in the gigapascal range, if I'm correct. And do you think that you can in the future also go down to the kilopascal range in order, for instance, to use your system with some physiological tissues and think about neuroimplants and to be in agreement with the very low stiffness of brain tissues?
Thank you very much for these interesting questions. Well, the point is to find the suitable polymeric matrix. Yes, and then we can help the polymeric matrix, and combining with graphene, we can basically achieve whatever we want. Of course, before creating our composites, we perform modeling to understand how our material can perform. So yes, of course, we can try this strategy. And the important thing is also to work on the thickness of the polymeric layers that we are using, and also in order to set the right volumetric fraction of the filler in the final nanocomposite. But yes, of course, and I would be really happy to collaborate on this kind of research project, if they can help, of course.
Thank you. So thank you once again for a very interesting talk, Professor Carbone. Thank you very much.
Thank you very much.
And wishing you a quick recovery with your voice.
Thank you again.
Ladies and gentlemen, now let's move on to the next talk. Let me invite the Dean of the Faculty of Chemical Technology, Professor Eva Kaczorek, and her guest from the University of Mons, Professor Sylvain Gabriel.
Good morning, distinguished rector, guests, ladies and gentlemen.
The Faculty of Chemical Technology represents the discipline of chemical science. However, the research conducted at the faculty is interdisciplinary, and today's lecture is an excellent example of such an interdisciplinary approach in the science. And it's my great pleasure and honor to introduce Professor Sylvain Gabriel from University of Mons. Professor Gabriel is a mechanobiologist whose research focuses on integrative tissue dynamics, cytoskeletal mechanics, and nuclear mechanotransduction. Trained in polymer physics and chemistry, he worked at several international research institutions, including Aix-Michel University, Harvard University, Stanford University, and the Mechanobiology Institute in Singapore. He focused his research group, the Symbiose Lab, at the University of Mons, and he is currently Associate Professor and President of the Research Institute for Biosciences. In 2025, he was awarded the prestigious Franke Research Professorship and serves as a Nikon Europe Ambassador for Advanced 3D Imaging in Mechanobiology. Professor, welcome at PUT. The floor is yours.
Good morning, everyone. So thank you for this very kind introduction. And I'm very proud and very happy to be here today. Thank you for the invitation at this Science Day. So my name is Sylvain Gabriele. So I come from the University of Mons in the Department of Chemistry. And I work on interdisciplinary research and out also to apply chemistry for studying life sciences. So I'm not only a researcher at the University of Mons, I'm also part of the UNIS consortium. So in collaboration with Ronnie Snyders and Mathieu Surin, two other professors in the Department of Chemistry, we started 2 years ago to work on a new master, on the UNIS master in bio-inspired chemistry. And we also collaborated with Magda and Marta at Poznan University, and also with Kristina to work on this master in bio-inspired chemistry. And you have here pictures of one of the summer schools that have been organized 2 years ago. And now we are part of this UNIS consortium, and we are also part of this collaborative network to work on multidisciplinary research. And I'm very happy about that. And we expect also, and we hope to be able to expand this consortium to other partners in the next couple of years. So as you may understand, my work is really interdisciplinary. So my work is really interdisciplinary, and I work on polymer physicochemistry and on forces and mechanics in order to better understand how cells can interact with the microenvironment and how cells can adapt to the modulation and the modification of the physicochemical properties of the microenvironment. One of the beautiful examples of the fact that we need to focus on the physicochemical properties of the cell microenvironment, the fact that there is a huge range, thank you, is that there is a huge range of stiffnesses in the human tissues. As you can see on this scale, we have very soft tissues related to the brain or fat tissues, but also stiffer ones for the muscles and cartilages. And all of these tissues span a wide range of stiffness. So if we would like to better understand how cells can adapt the range of mechanics, we need first to look at their internal structures. And you can just see on these slides one of the seminal works that have been done at Harvard by Donald Ingber, showing that we need also to look at the fact that the cell, inside the cell, there is an internal structure, the cytoskeleton, that can help the cell to adapt and to exert forces. You have a beautiful example in this movie of one contractile myoblast, one cell, one earth cell that can be contractile
and that can exert forces due to the reorganization of the fibers inside the cells. And there are beautiful examples of the fact that we can also use some architectural design in order to better understand how these filaments can reorganize in space and time. Yeah, you can see there on this optical micrograph that you can also observe the organization of these actomyosin filaments that help the cells to exert forces. So we know that we have to pay attention to forces and mechanics to better understand how cell will also activate specific genes. And in fact, there is also other interesting aspects of the adaptation of cells. We also need to pay attention to the extracellular matrix. So the cells is continuously in interaction with the surrounding matrix, and the cells need to adapt, need to sense, and also need to interact with the surrounding matrix. And there are beautiful works that have been done 20 years ago by Dennis Disher, for instance, at UPenn in the USA, showing that we can only change the stiffness in order to modulate the differentiation of cells. So there is no biochemical changes, there is no other effect, we just have to change the mechanics. And just by tuning the mechanics of substrate, if you plate cells on very soft, on intermediate, on very stiff matrices, you will get different cell types after differentiation. You can see on this graph, if you plate cells on very soft substrate, you will get neurons. If you plate cells on intermediate stiffnesses, you will get myoblasts, these contractive cells. And if you plate exactly the same cell in exactly the same condition on very stiff substrates, you will get osteoblasts, you will get bone cells. So what does it mean? It means that if we would like to better understand the role of the cell microenvironment, we need not only to focus on forces and mechanics, but also of the physicochemical changes of the cell matrix. And interestingly now, if you use specific drugs in order to inhibit the contractility, if there is no mechanosensing, if the cells cannot directly recognize and sense the stiffness, there is no differentiation. It really shows us the intimate link between forces, mechanics, and the cell microenvironment. And in my lab, we try to find a way in order at the bench to modulate step by step the physicochemical property of the cell matrix in order to better understand how cells can adapt, and then in the next few years to design advanced biomaterials. So recently we were invited to publish a review paper about the fact that we can use now all the potential of this mechanobiology, the fact that we need to pay attention to mechanics in order to better understand some specific disease and also to advance the field of the therapeutic potentials. And so this work were published in October 2025, and very interestingly, just a couple of weeks ago, there is a beautiful science paper coming out from another group showing that the mechanical load can inhibit the cancer growth in the human hearts. What does it show? It shows exactly what we thought. We have a very specific way in order to inhibit or activate some specific cancer just based on the mechanics. So there is a causal link between cancer progression, mechanical forces, and the matrix physicochemistry. And during this talk, I will try to show you a few examples coming from my group and how we can apply chemistry, forces, and mechanics in order to better understand the propagation of very specific cancer disease. So let's have a look to the breast tissues. So that's sketches of the internal structure of breast mammary tissues. You have these normal ducts, these very thin tubes connected to these lobules, this hemispherical shape. So there is very specific architecture. So if there is a starting progression of the cancer, you have these intermediate states where there is a huge growth of abnormal cells, but no dissemination. That's really the intermediate stage of the breast cancer. And you have the final stage where you have these invasive cancer cells that can disseminate from the tumor mass and also directly grow in other organs and tissues. And if you look at the balance between cancer in the duct, in the tube, and cancer in the lobule, you have a larger cells connected to the duct instead of the lobules. So the first question is, why do you have so many cancer in the duct and not in the lobules? So if you would like to answer the questions, you can not only have a look to the biochemistry and to the gene expression, but you can also pay attention to the internal structures of the mammary tissue. If you look at the duck, you have two different curvatures. The red one and the blue one. The blue one is equal to 0. That's the zero Gaussian curvature. And if you look at the structure of the lobules, you have two different curvatures, but all of them are positive. So first of all, cells will sense different forces coming from the fact that they are not located exactly at in the same zone of the breast mammary tissue. And we can think that these differences can lead also to the tumor propagation. So let's have a look to the role of the matrix curvature in breast cancer progression. It will be the first part of this talk. So Marine in my lab, so a former PhD student, Marine Luciano, so she went after that in postdoctoral studies in Geneva, in Switzerland, and she's now back in my lab as a FNRS chargé de recherche. She decided to have a look to the curvature in living tissues. As you can see, there are not only curvature structures in the breast, but there are curvature everywhere. All the epithelioles of your body are curved. You have in the bladder, in the brain, in the kidney, in the intestine, all of them are curved, and so we can think that this curvature can affect the disease and also the behavior of cells. And so we decided to find a way, as a chemist, to modulate this curvature at the bench, to mimic the curvature that can be observed in the tissue. So we designed a new, very soft hydrogels, and just by using light, in order to photopolymerize these hydrogels and specific optical photomask, you can stop the UV light or let the UV light pass through this mask. And assuming the fact that there is a different dose of UV light that will photopolymerize the gels, finally, we can get a modulation of the structure of the gels. So we can get very soft gels, exactly like the mammary tissues, but also curved gels that will mimic the curvatures that can be observed inside the mammary breast. So you can see there, so on these curved gels, we can seed cells and obtain a very beautiful monolayer of epithelial cells, of mammary epithelial cells. And in collaboration with Edouard in Austria and Shelley in China, we decided to not only focus on the cells, but also on the internal architecture to better understand how intercellular forces can adapt in order to let the cells adapt to the curvature imposed by the hydrogels. So we can now, in the lab, mimic exactly the stiffness and the architecture of breast tissue. So we observe that inside these curved substrates, we have a huge accumulation of nucleus. As you may know, the nucleus contains the DNA. So if we can change the localization and the shape of the nucleus, we can directly also affect the gene expression, which is obviously of interest if we would like to better understand the breast cancer propagation and disease. So if you have a look to this image, we have a huge accumulation of the nuclei inside the valley, as you can see on this sketch. So, and we also not only have an accumulation of the nucleus, but we also have very different shape of the nucleus. So if you can see on this movie, we have very flattened nuclei on top of the crest due to the compressive forces acting on the nucleus. And we also have this beautiful elongated nuclear shape, which are directly related to the fact that we have a huge accumulation of nuclei inside the valley. So the curvature not only changes the localization, the spatial localization of the nucleus, but it also directly affects the shape of the nucleus. And if you look inside the nucleus, you will see that the modulation of the nuclear shape also directly affects the condensation of the DNA. So what does it mean? It means that by just changing the shape of the nucleus, you will not only affect its overall shape, but you will also affect how the DNA is compacted, and you will affect the gene expression. So we can expect that in different ductal structures and different mammary structures, the role of the curvature can help us to understand why specific genes can be expressed or not, depending on the overall architecture of the breast tissue. So that was the first step. So we started to have a look, and then we tried to better mimic these specific shapes. So we change the curvature pattern. As you can see in this beautiful image, we can make the lobules, so not only the ducts, we can also directly reproduce exactly the shape of the lobules inside the lab, and so now we can use this platform in order to test some drugs and to look at the effect of these drugs in order to inhibit the cancer progression. And more recently, we decided to go to not only static curvature, so we can impose some static curvature, but we can now also impose dynamic curvature. So what does it mean? It means that now in the lab, in collaboration with one of my PhD students, Rémi, so he designed this beautiful microsystem, and actually you can see there, we can inflate directly the tissue in order to mimic the change of curvature over time directly at the bench. So we have a specific microsystem to design exactly the modulation of the curvature and to mimic what happens in any curved tissue in the human body, which is very helpful to understand what happens during the progression of a lung disease, for instance, not only in breast tissue. Well, so I show you the first part about curvature, so all the main architecture of the breast tissue can affect the cancer progression. And there is also another very interesting part, viscoelasticity. As I said at the beginning of my talk, there is a modulation of the stiffness of the breast tissue, but not only the stiffness, but also the viscosity of the tissue. So we will have now a look about the matrix viscoelasticity in breast cancer progression. So with Giuseppe Ciccone coming from Glasgow, so I spent a few months in my lab, and in collaboration with Manuel in Spain, we decided to design a new hydrogel as a chemist, you know, in order to mimic the viscoelastic properties of these breast tissues. So we were able to mimic very soft and healthy breast tissues, but also to mimic exactly the same mechanical properties of tumoral breast tissues. And by using these gels that can directly show us how the tissues can, the mechanical properties of the tissue can change over time during the cancer progression, we can now exactly have at the bench a system that can mimic what people observe directly in tumoral tissues by looking at the stiffness. So we know that there is a huge modulation of the rigidity and also the dissipation inside the tissue, and so we made soft elastic, soft viscoelastic, stiff elastic, and stiff viscoelastic substrates, and we culture mammary cells on top of them in order to have a look step by step about the effect of the stiffness and the effect of the dissipation. And I will make the long story short. Interestingly, we have shown that if you play with the viscoelasticity and if you look at the mammary cell, at the speed of the mammary cell, you will see that the speed is not affected, is not really affected by the stiffness, but now, if you have a coupling of the stiffness with viscosity, you can drastically reduce the speed of the mammary tissues. So what does it mean? It means that just by changing the mechanical properties of the surrounding tissues, you can directly suppress the cancer dissemination. So now, if we can find a way, if we can find a biochemical way in order to modulate the viscosity of breast tissue, we will be also able to inhibit the cancer progression because we will be also directly able to lower the speed of the disseminated cells. So it's a first step towards a new substrate and new biomaterials that can help us to inhibit cancer progression. And for the last part of this talk, we will now pay attention to confinement. So what does it mean? It means that inside breast tissues, cells are compressed. When the tumor mass grows, the tumor mass will also directly express compressive forces on other tissues. And as you can see on these beautiful images, here is a nucleus, here is a compressed nucleus due to the fact that there is a huge tumor mass growing around. So cells need to find their way and to squeeze in these compressed tissues, and that's exactly what you can observe in this beautiful movie. You have one cell, in blue you have the nucleus, in purple the cytoskeleton, and in green you have, I will play it again, and in green you have the fibers of the extracellular matrix, and you can see that the cells need to find a way in order to squeeze to the collagen fibers and to disseminate and propagate. So we need to understand how this level of spatial confinement can help or inhibit cancer dissemination, right? So this is the last step of this work. So I will show you a few recent works that have been done in my lab about the role of the spatial confinement in breast cancer progression. Unfortunately, that's very difficult to follow one cell moving inside a 3D matrix with an optical microscope. So we need to find another way in order to impose boundary conditions and confinement to these moving cells, right? So the idea was to use a very simple chemical way in order to form these protein micropatterns. So by using this light-induced molecular absorption, so we use a UV light in order to change the chemical functionalization of a substrate, so we can have these beautiful micropatterns. So what does it mean? It means that you can create, at the micrometer scale, at the scale of one cell, a very small island of adhesive proteins. Everything around is non-adhesive for the cell. Only this very small patch is adhesive and has exactly the same biochemical composition of the surrounding matrix in the body, right? So the cells will interact with this very small island, and if you make it circle, you will get a rounded shape, okay? If you make this micropattern with a triangle, you will get the cells spinning on a triangle, so you can make every kind of geometries, you can change the biochemical functionalization, you can obviously, so for instance, the growth of neurons on the lines, and you can make very complex shape up to growing cells and neuronal cells, for instance, on this very beautiful network in order to mimic some neuronal network in interaction in the human body. So we used this patterning system in order to make a thousand of patterns on a very small cover slips, okay? And if you zoom in, you will see that inside these cover slips, you have many patterns. So it gives us also access to a lot of statistics. So we can impose this boundary condition. We can impose to one cell in green very specific spatial confinement and look at the migration of all of these cells on these micropatterns in order to get some statistics. So that's exactly what we did, and the idea was to mimic what happens inside breast tissues. So in these beautiful movies, you can see in grid the nucleus of tumoral cells, tumoral mammary cells, trying to find their way inside the collagen matrix. As you can see, there is here the tumor mass on the left, and you have the formation of this line of cells that are trying to find a way inside and squeeze inside the matrix and form these cell trends. And at the tip of these cell trends, you have some individual cells that try to disseminate and to progress inside this crowded tissue. So with Danae, one of my former PhD students, we started to look at the adaptation of one cell, only one mammary cells, as a function of different contexts of confinement. So we plated these cells on adhesive micropatterns of different width, from 5 micron to 21 micron. You can see now the progression of these cells, moving from one segment to another one, and trying also to adapt its shape to the level of spatial confinement imposed by the boundary conditions, because the cells can only spread on these adhesive micropatterns. You can see that there is a modulation of the shape, so the cells can dynamically adapt to the spatial condition imposed by adhesive micropatterns. And you have here the graph of the speed, and the speed increases accordingly to the width of the micropatterns. At the border of the micropatterns, the cell will repolarize, find the way, and go to the opposite direction. So we can make it overnight for days and days and days and look at the cell speed adaptation to the level of confinement, and that's exactly what happens inside mammary tissues, right? If you have a very crowded environment, the cells need to find their way and to progress and to adapt its shape directly in order to find a way to speed up or to lower the speed and to progress inside this mammary tissue. So it was a beautiful observation that there is a direct readout of the cells to the spatial condition and the direct adaptation of the cell speed to the spatial condition, right, to this confinement. But we didn't exactly understand the mechanism behind how cells can really adapt its own speed to the level of spatial confinement. To better understand that, Danae made a very crazy experiments So she decided to take off an FM cantilever. So what is a cantilever? It's a flexible substrate, okay, that is normally used as a nanoscale, but we know exactly the stiffness. And she placed this, she glued the cantilever on a glass micropipette, and on top of the microscope, she just placed this elastic cantilever in front of her migrating cells. If you look at this side view, this is the head, the top side of the moving cells. This is the rear and the body with the nucleus. So inside this very flat lamellipodia, this is the front protrusion of the cell. The cell is going from left to the right, which is super, super thin, about 100 to 200 nanometers thick. She was able to place the cantilever in front of the lamellipodia. And she looked at the deflection of the cantilever due to the protrusive forces exerted inside the lamellipodia, okay? And just by looking at the deflection of the cantilever, we were able, you can see that maybe on the movie, so I will play it. If you look at the cantilever, you will see that when the cell touches it, there is a very small deflection, just very small deflection. If we look at this small deflection, assuming the fact that we can tune also the level of confinement, we can get this very simple graph. This is the amount of forces exerted by a cell as a function of the level of confinement. And you can see that the spatial confinement on very, very thin segments, we can reduce the protrusive forces, and then if you extend the width of the micropatterns, the cell will adapt the protrusive forces, and we can exert a larger amount of protrusive forces. So this is why we have such an adaptation of the cell speed as a function of the level of confinement. So we understood the internal mechanisms that can explain how cells can dynamically adapt their own speed to the level of confinement, and can also explain how cells can escape from a mammary mass and try to invade other tissue. So that was the first step at the single cell level, and the second step was to try to find a way to make these cell trains. We were super interested into the fact that cells need to assemble together to make these very small cell trains. One cell, connected to another one, and another one, there is a very small row of cells. And Eleonore in my lab tried to find a way in order to mimic the organization of these cells. So by using lines of micropatterns, very thin lines of proteins, you can see there is an expansion of the tissue break, and forms these very small clusters of cells, which are very, very, very which look exactly like the cell trains observed in the mammary tissue. You have here a beautiful example of one cell trains. So we can follow the progression of these very, very small cell trains in very standardized microenvironment and look at their speed. And interestingly, we didn't see any modulation of the speed as a function of the number of cells inside the cell train. So it was quite unexpected. So even if you have one cell, two cells, up to 10 cells inside the cell train, all of them have exactly statistically the same speed. So we expected that the larger the cell inside, the number of cells inside the train, and the lower will be the speed, but no, there is no modulation of the cell speed. So we decided to expand the width of this cluster, not only have one row of cells, but multiple rows of cells. And in collaboration with David in Switzerland, Edouard in Austria, and Xavi in Barcelona, we found a way to explain why when we expand the width of this cluster of cells, we have also a decrease of the cell speed. So what does it mean? You can observe this experimentally, but also theoretically. What does it mean? It means that when you have one row of cells, you don't have any stresses inside the tissue, and there is a perfect adaptation of the cells that can invade efficiently the tissue. But now, when you increase the width of this cluster, the larger the cluster, the lower the migration speed, and obviously you are less efficient in order to progress to the matrix and also to disseminate cells. So that's the reason why this is the most advanced and the more efficient way in order to progress within a mammary tissue, and that's the reason why we observe such a cell train inside breast cancer tissue. And in the last part of this talk, I will show you that cells can also have a memory of the confining events. So this is the work of Yoali Kalukula. She defended her PhD last year, and she is now a postdoc at the Max Planck Institute in Germany. So she decided to ask such a question: can migrating cells retain a memory of past confining event? So if we would like to adapt better, we should find a memory of what happened in the past. So that's the main, that was the main idea, trying to focus on the memory of cells. So to do that, we design a dumbbell micropattern. So this is an adhesive micropattern with a very small bridge, only 6 microns in width, very, very tiny bridge, when cell need to squeeze, and connected to 2 large squares. So if you look at the adaptation of these cells, the cell will try to migrate from one square to another and need to pass this very small bridge. So we have such a level of confinement that can be observed in mammary tissue. And we can look on this force and back motion over time on these cells on this very beautiful bridge. So we can do that and extend the length of the bridge in order to see if the cells can be able to pass through this bridge. Well, from 40 micron to 80 to 120 up to 160 micron, which is related to very, very long confining events. Let's have a look to these movies. And as you can see, to the final one, the cells can efficiently progress to the longer bridge, which is also quite unexpected, right? If you extend the length of the bridge, the cell will efficiently pass through, and which is not exactly the case for the other ones. So we decided to focus on this very long bridge, and we observed there is 2 subpopulations. So the cells can adapt its own morphology to the bridge. The cells can be compacted or can be elongated. It depends on the time. There is a switch. And if you look at these 2 specific morphology, one elongated, you can see there the elongated ones. And if I can play it again, you will see that you have some compacted morphology. And if you look at the speed, you have a huge difference in migration speed for the elongated versus the compacted one. The compacted morphology of the cell is 3 times faster than the elongated one. So it means that dynamically, cells can adapt its own shape in order to pass through and to be efficient to pass through. So we looked at the different crossing events. This is the first one, the cell passed first time. The second one, right? This is the third one. The fourth one, still compacted, and the 5th one. And we can do that for a very long time. This is the number of hours that we recorded the movies on top of the microscope, up to 24 hours of time-lapse movies on top of the microscope, in order to understand what happens for one cross to another one, if the cells can remember the previous cross, right? So if we would like to decipher and to determine if there is a mechanical memory, we should have a look to the statistic of the successive crossing in a compacted morphology in pink or in the elongated in orange, right? So at the beginning, it's 50-50. You can be compacted or elongated, right? There is no other statistics. It's exactly what happens when you flip a coin, okay? You can have such a statistic, 50 and 50 to get one side versus the other one. This is the probability that you can expect with no memory. The probability to be elongated during the first cross of compacted, and then this is the second cross, the probability to be elongated when you were elongated during the first one, to maintain the compact morphology and all the other transitions. This is the experiments. As you can see, we are not at the 60-60 situation. We have a modulation of the statistics, and that's exactly what we observe also theoretically. So there is really an emergence of a long time scale memory of shape. So the cells can retain the previous shape in order to maintain its compacted shape and to pass more efficiently to the successive crossing events. So what does it mean? It means that the cells can dynamically adapt its shape, but also its internal structure in order to pass through mammary tissue, and that's the reason why tumoral cells are very efficient to disseminate, because they can remember the fact that they were confined, and they can dynamically adapt in order to retain the best shape. And that was the last movie that I would like to show you. I will show you that the cell can adapt and cross all of these dumbbells efficiently and to be more compacted and speed up. And that's exactly the reason why this mechanical memory can help us to better understand the dissemination of breast cancer. Well, I'm at the final slide of this work. So obviously, we will not only focus on healthy breast cancer cells, but we are now also very interesting to look at this intermediate stage, the lobular carcinoma in tissue, where cells grow and expand, but without dissemination. And I will just show you this final slide with what is going on in my lab. Now we are collaborating with Giorgio, with Sarah, a new postdoc, but also Stefania. She's a uni student. She spent a master study in my lab, and she's now coming back for a PhD. And we are trying to understand this intermediate stage of the breast cancer progression, the ductal carcinoma. And we are also trying with Marine, a chargé de recherche FNRS in my lab, trying now to go at the 3D conditions. So I will focus on the 2D, and Marine is trying to expand this work at the 3D condition to make this beautiful tumoral sphere in collaboration with Sarah Elshorn at Stanford, and we hope to be able in the next couple of years by combining the 2D and the 3D aspect to really better understand, as you can see there, the invasion of this tumoral cell in breast tissue. And I thank you for your attention, and I will also thank all of my collaborators and the people of my group for the huge work. Thank you very much for your attention.
Thank you very much. Thank you very much indeed, Professor Gabriel. Are there any questions from the audience that we would like to ask Professor Gabriel?
Thank you very much. Very nice presentation. Really
Thank you.
Nice. I have a curiosity if I got correctly your point. You said that different mechanical action on the cell may impact on the DNA expression, and that means that the mechanical action can directly in some way impact on the translation, right? And do you have any detailed information about the, for instance, different behavior of cancer cell and healthy cell in this respect, or this is something generic that happen in any kind of cell in the same way, or maybe different cells may, I don't know, produce different expression of a certain part of DNA compared to others, or things like that? Thank you very much.
Thank you for your question. That's a very good question. Yeah, in fact, there is a general mechanism which is called the mechanotransduction that can explain how any kind of cells can sense the surrounding matrix. So cells can establish some connection with the matrix called focal adhesions, and this connection will connect the external microenvironment to the internal structure through the cytoskeleton. And all the tension that cells can exert contracting forces, and all of these forces will be connected to the nucleus. And then, due to the fact that there is some specific protein connectors from the cytoskeleton to the nucleus, to the nuclear envelope, we will have a modulation of the compaction of DNA and gene expression. Your question is very interesting because we don't know exactly how it works for any kind of cell types. So it's the gene expressions that will be directly modulated by the fact that we can tune the cell microenvironment, and the physical-chemical properties of the cell microenvironment will directly depend on the cell types that we'll focus on. If you look on bone cells, for instance, you will not activate or inhibit the same gene expression depending on the physical-chemical properties. So that's the reason why there is a lot of work to do, because for each cell types, we need to better design exactly what happens, and also to understand the mechanotransduction pathways, that will be activated in very specific cell types. There is a beautiful works that have been done, for instance, for neuronal cells. People have shown that usually cells are going from the soft part of a substrate to the stiffer part. They really like to cross a gradient of the stiffness, but very specific neuronal cells are going to the opposite. And that's something people need to better understand, especially for the formation of brain tissues. So that's something very interesting. It really depends on cell type.
Okay, thank you very much indeed once again for a very informative, very, very good presentation. I think we've run out of time. Thank you. Okay, so ladies and gentlemen, now let's move on to the next talk today. I would like to just remind you that there are display units that can be seen by both the audience and the presenters here, showing you the elapsing time, which is 35 minutes. So now I would like to invite the Dean of the Faculty of Control, Robotics and Electrical Engineering, Professor Wojciech Szelong, and his guest from the University of Catania, Professor Salvatore Graziani.
Good morning, distinguished guests, ladies and gentlemen. It is a great pleasure to introduce our next speaker, Professor Salvatore Graziani. Professor Salvatore Graziani received his PhD in electrical engineering in 1994 and has been full professor of electrical and electronic measurement since 2022 at the University of Catania, where he is with the Department of Electrical, Electronic and Computer Engineering. From December 2012 to October 2020, he served as head of the bachelor program in electronics engineering at the University of Catania. He is currently deputy director of the Department of Electrical, Electronic and Computer Engineering. Professor Graziani is the vice president for education of the IEEE Instrumentation and Measurement Society, editor-in-chief of the Society Video Tutorial Program, and associate editor of IEEE Transaction on Instrumentation and Measurements. He coordinates the Laboratory of Polymeric Transducers, and he has served as reviewer for numerous international journals and conferences. His main research interest includes soft sensors, noise-affected measurement system, polymeric and via-derived sensor and actuators. Today, the professor will give us a presentation titled Designing Sustainable Motion Sensor, the shift from polymeric to biopolymeric materials. Professor Graziani, the stage is yours.
Okay. Good morning to everyone. Thank you for the nice presentation. Thank you for inviting me to this conference. And today, okay, I will skip my presentation because it has been already given. I will give today a presentation about the evolution of my research activity in past, let's say, 20 years. And more specifically, I will explain why during my research activity, our research activity, we moved from some technologies to newest technologies because there were some properties that we were in search for that we were not able to find with the previous one. And for each of these technology, I will try to give you a proof of concept, a sensor that we developed to show what we can do with that technology. More specifically, I will show you why and how we moved from polymer-based self-generating motion sensor to biopolymer-based self-generating motion sensor. Let me start with an introduction and the motivations. We start with the need to implement sustainable development. This can be obtained with conventional electronics. More specifically, we need technologies that need less energy, do not need no renewable or critical materials, and do not produce pollutants. Also, we would like to use technologies that use less energy or non-related fossil fuels. And at the end of the day, much more interesting, we need devices and technologies that can be, after the usable life, can be safely disposed of, recycled, or even better, biodegraded. This cannot be obtained with conventional electronics. And this is because the ordinary silicon industry requires relevant amounts of non-renewable raw or critical materials, energy, and fresh water. Moreover, even much more interesting, electronic waste is nowadays a very significant topic. Just to give you an idea of what are the numbers we are talking about, waste is expected to increase significantly. What you can see there is 10 years now old figure, 44.7 by 10 to 9 kilograms of e-waste generated in 2016. And even more interesting, it is the fastest growing e-waste stream in the EU, and only 40% of the produced e-waste is actually recycled. The rest is just land to landfills, well, which consumes soils, or even worse, land to developing countries where non-well-educated, well-trained workers can develop, are at higher risk of developing work-related pathologies. We need, therefore, to develop what we call green electronics, which propose implementing new products, technologies that require less energy, do not need non-renewable materials, and can be, at the end of the usable life, safely disposed or recycled. But based on this premise, I will show you how we started from non-polymeric and green devices, and moving from this class of devices, we moved to all polymeric devices, because in that case we were interested in flexibility, playability, low cost, but being polymeric by itself does not mean being biodegradable or environmentally friendly. Just to give you an example, plastics, polymer, synthetic plastics are not biodegradables, and you know what issues we have with the microplastics. So because of that, in a second step, I will show you how we moved from polymeric-based sensors to biopolymeric-based self-generating sensors. This is just an overview. I will not talk about all these devices. I will not have the time and these technologies, but I will give you just a few examples. Let's start for the first one, which is called IPMC. It's now some more than 25 years old technologies. The very first works were produced in 1992, I guess, and it's called ionic polymer metal composites. They are based, the names come from the structure. This is the chemical structure of the polymer. What is interesting is that you have a backbone based on fluorine, and then you have side chains where you have a sulfonic group, which is only weakly linked to a positive charged ion. And I will show you later, this part is the most interesting to generating the mechanoelectrical subduction phenomena. The movable cation can be hydrogen, or can be lithium, or can be sodium, while the sulfonic group is fixed. The rest of the name comes from metal. Generally, platinum is used to design because they are generally used in wet environment, and C is just for composite because this system is a 3-layer structure. This is what they look like. What you see is the platinum deposited on the surface of this 3-layer structure. It is deposited by a chemical reduction process because Nafion is very anti-adherent. You cannot just easily deposit the platinum. And this is yes, I have, oh no. How can I start it? I wish to start the movie. If you click on. Okay, this is just to give you an idea of how it works. So you are deforming the IPMC in beam configuration. And here you have the oscilloscope. In yellow, you can see the applied deformation. In pink, the produced signal. We can go forth. Now, let's start to understand what are the origin of the sensing properties of IPMCs. They depend strictly on the structure and depends on the migration of ions inside the membrane. There is a porous membrane because of the mechanical stimulus. This is just a graph of what's happened, and this is a better view where you can see that in the absence of any deflection, this one, no. In the absence of any deflection, you have ionic positive and negative charges close to each other. But when you have a deflection because of the gradients in pressure, you have a migration of the mobile ions that are only weakly linked to the backbone, and eventually the presence of a polar solvent like water further makes weaker this interaction. So you can have the motion of the charge. And this motion of the charge, this is just a magnification, comes from the possibility to have that H ion or lithium or sodium to be detached from the fixed part and to move according to the external stimuli. Again, this is when it is undeformed, and this is what's happened when it is deformed. More interesting, this system is also, the Nafion is a dielectric, and you have metallic parts on the both sides, and since you are deflecting them, you are accumulating charges, so that these charges can be transformed into either an open circuit voltage or in a shorting circuit current according to the conditioning circuitry you are considering, you are using. What you can do with these devices? This is just the first example for this class of sensors. Like piezoelectric devices, piezoionic devices cannot produce a signal in the presence of a constant deformation. So you need a continuous varying deformation, and you need to develop applications that respect this limit. So the solution is to move from a constant quantity to a constant quantity that produces a continuous varying signal. And this can be done if you realize a flow meter. We realize the flow meter, which is based on the vortex shedding phenomenon, where our FMC works as a secondary sensor, while the primary sensing element is the bluff body. Okay, this is a very well-known concept. If you have a body, whatever is the shape, but let's consider the cylindrical body that is immersed in a fluid, and you have this flow in a pipe, and you have this flow across the bluff body, you have that the impinging fluid produces vortices. And moreover, what is even more interesting, the vortices are produced on the opposite, alternatively, on the opposite sides, phases of the bluff body, and the frequency of this vorticity can be linked to the speed of the fluid. This is a schematic of what's happened at the separation area, and this is an evidence. It's called the von Kalman vortex sheet. This is taken in our lab. The circle that you see is a photo of the bluff body, and the two white lines are there is the tracer that give evidence of the created vortices. What is interesting is that as the velocity increases, the frequency of the vortex shedding increases as well, and they are linked by the Strual number according to a very simple equation. You have that the frequency and the velocity u are in direct proportion. Actually, the Strual number is not a real constant. It depends on the Reynolds number, which is reported in this equation, but there is a big range of values of the Reynolds number where the Strual number can be considered equal to 0.21, and this is useful because then you can use the first equation to estimate the velocity according to the frequency. We realized that based on this, hypothesis, we realized that our system that consists of a shader, a plastic body, our IPMC sensor that works as the secondary sensing element and that vibrates according to the forces created by the Wurtzing shedding, and of course we have a pipe to have a flow of fluids. This is a schematic, a 3D schematic of our system. You can see the bluff body, and you can see the RPMC on the top part of the 3D representation. Once we have realized the system, this is the design of the system. This is the real device. It's magnified, of course. It's some centimeters big. This is the real dimensions of the devices. We realized the two of them. And after we realized them, we realized an experimental rig with a tank, a pump, and a reference flow meter for characterizing the system. This is, again, a 3D schematic of the experimental rig, while this is a photograph of the lab prototype system we realized. On the right-hand side, you can see a magnification of the flow meter immersed, not immersed in the fluid in this case, but mounted on the tube. Once we have realized it, we recorded the signal to understand what's happened when the fluid changes, and you can see that for low speeds, the signal is quite low, and the frequency is low as well. Well, if you increase the speed of the fluid, poor water in this case, you have a shift of the frequency of the peak in the spectrum at higher frequency. You can see actually that the signal looks quite noisy. Of course, it is not of constant amplitude. This is not a real issue because this flow meter uses a semi-digital measuring principle because it is based on the frequency, on counting the frequency, and not on the instantaneous amplitude of the signal. Okay, once we have those data, we processed those data, and this is the first simulation that we did, the elaboration that we did when the velocity is measured as a function of the estimated frequency, while in a second step we performed the system calibration. So here you have the estimated velocity as a function of the real velocity as measured from the reference sensor, and we of course estimated the corresponding calibration curve and the standard deviation. Okay, this system was the first class of devices that we realized. But realizing a system by using polymers to obtain self-generating sensor is a recursive activity where you propose some devices, then you have new materials, and you try to use these new materials to create new devices. This is what we did with the second class of devices that we proposed, and we named IP²C, which means ionic polymer composites. The reason of this change in the name depends on the structure of the system. The main difference is in the electrons. Conventional devices use Nafion as the bulk, but use platinum as to realize the electrons. Platinum is very expensive, and not even if it is a noble metal and it's biocompatible, the reduction process is not green at all. It requires explosive or toxic material. Nevertheless, in the meantime, conductive polymers became available on the market, and this is why we proposed this second class of sensor. The structure is very much similar to the previous one. You have the three-layer structure, but if you can see, you have not anymore the platinum to realize the electrodes, but you have the P.PSS, which is the polymer we use, the conductive polymer we use to realize this device. We proved that they can generate electrical signal when they are deformed. They are light, soft, pliable, but they are much more safe. The production is much more safe, and it's much less expensive. Okay, this is just to summarize what are the differences. The production lasts 1/4 an hour, lasts 1 day instead than 5 days, while the cost is reported on the last sentence. Of course, this is based on lab materials. The cost can be even cheaper if you use large-scale production procedures, which was beyond our interest. What you can see in that figure is the ordinary IPMC device and the new IP²C device. The difference on the shape, on the sides, is not of any relevance. It's just us that cut the device in different shapes. What you can see is that the silver-like surface disappear, and you have the bluish color on the top. That is because of the P.PSS. Once we realized this device, we also thought about possible applications. And what we realized was a self-generating analog touch system, which used a couple of IP²C deformation sensor used in a differential configuration. This is the idea. You have this touchpad. You touch it in a point, and at the two ends you can see these two strips of sensing element that produce different signals according to the point you are touching. The basic idea is that if you touch at the center, the two signals are equal and they disappear. The sum will be 0. But if you move on the right, on the left, the signal becomes different, and you can collect two voltage signal and differentiate that, subtract that to obtain the final signal. Okay, this is just a schematic that we used with the quantities used to model the system. These are the equations that we derived. They are not very hard to be obtained. These are the equation of fixed beam. But what is interesting is the last equation, where you can see that the deflection, the output, is in direct proportion plus some other quantities to the deflection you give to the system. Then we made some simulation, and on the right-hand side you can see how the output voltage should change according to the touching point. It's a nonlinear point, but you can even, a nonlinear equation, pardon, you can even approximate them with a linear approximation. We performed a different approximation. Once we have the data and the model, this is what the real system looks like. The second picture is the device when it is realized. Then it's cut into strips, mounted, and then mounted on the final devices. Then it was investigated in our lab, and this is the final result, when you can see that changing the touching point, you can obtain the system output. Eventually, the system output is after an amplification of the final result, of the final signal. Okay, let's move to the third part of my presentation, which is a different class of devices. What is the problem? As I told you, polymeric composites play a relevant role in the development of new sensing systems. They are playable, they are flexible, that it can be used for wearable devices, but unfortunately they are ungreen. So we can have some nice performance, but we might have concerns about the green properties of these devices. what you can do. You can move from polymers to bipolymers. Of course, cellulose is the most obvious solution because it's ubiquitous, it's flexible, it's non-toxic, of course, and it's totally biodegradable. It dissolves in weeks when it is just left on the environment because of fungal biodegradation. The problem is that cellulose by itself is not that green. I mean, the production process is not that green if it is obtained from vegetal stocks. Also, it is obtained as the result of the pulp industry that requires relevant quantities of water and energy. Eventually, pollutants are released to the environment. Maybe there is a better solution, which is the use of bacterial cellulose. Bacterial cellulose is directly produced by some bacteria. It is produced provided that it is maintained in a typical lab environment where you have a culturing media, you have some feeds, some food, which is essentially sugar. It can become also as a bioproduct of alimentary, of food industry, and it does not require energy. It just digests this sugar and produces cellulose at the interface between the growing media and the open air. The system, this gel is that yellowish layer that you can see on the photo. Then the bacteria that you can see in that micrograph can be washed off, and you finally get this network of pure cellulose. The problem is that, unlike the IPMC I have described so far, you need mobile charges. And cellulose is not piezoionic by itself. It has just a light piezoelectric properties, so you need to use some kind of mobile charge. And this can be done if you use ionic liquids. They are salts that are liquid at the environmental temperature, and there are virtually infinite many ionic liquids available on the market. So the process becomes like this. You have now bacterial cellulose, you have some ionic liquid, which is ions, and you have the electrodes on the opposite surface. We created it with a different process now. You have the preparation of the BC, you have to dry it, and to further eliminate any residual humidity. After you are sure that the system is dry, you can absorb ionic liquids. It occurs in typical labs. You do not require very complex devices. And finally, you produce the electrodes by using a spreader, with P.PSS. Once they have been obtained, this is the SEM of the BC with ionic liquids, and you can see that the chemical structure has been changed, and finally a SEM of the electrodes. Once we have obtained it, we realize it, we cut it in different shapes and to obtain the desired geometry. And as I explained before, we perform some experimental investigation. You can see here a magnification of the BC in beam configuration. You have two red spots. There are two lasers used for measuring the beam deflection. By using this system, we investigated its mechano-electrical generation properties, its characteristic in the frequency domain, and finally we realized, this is again in the spectrum, and we realized an acceleration. You can see here that the output of the system changes almost linearly with the applied acceleration. So this is an example of ionic liquid bacterial cellulose-based accelerometer. Again, we changed the technology because some ionic liquids have raised concerns about their biotoxicity, so we moved to other classes of ionic liquids. I told you there are infinite many ionic liquids, and there are some interesting biologically generated ionic liquids like choline, and choline malonate. It's available on the market. Choline is present in our body. It's a nutrient, and it is not biotoxic, so it's absolutely safe. So we realized again our system, but in this case we used choline malonate, which is bio-derived. This time we realized that the device, of course, nothing new in this strip. We have seen it for a while now, are our devices. And we experimented the possibility of using them for realizing an accelerometer. If you look at the metrological characteristic, you will see that they are not as good as the case of the MNBF4 based ones. But this is what we suggest as a conclusions. When you think about sustainability, metrological characteristics should not be the one parameters to be considered. In this case, the idea is to have a trade-off between the metrological characteristic and the environmental impact. Finally, this is the latest devices we are talking. I will talk to you about. It's where you move from a finite time device to dissolvable devices. It's when you use electronics, you accept that, and you want that they have infinite lifespan. And in this case, and after the useful life, they just disappear. What we used in this case, again, a biopolymer. In this case, we used pullulan. It is an edible and non-toxic biopolymer. It is used in the cosmetics, in the agriculture, is used in the food industry as an additive to many food. And this is the chemical structure. What is nice, it is that it is biodegradable and even dissolvable in water. This is what's happened in less than 3 minutes. You can see the white strip that after 150 seconds disappear completely in the water. We realized that these the usual 3-layer structure, in this case we used silver to realize the electrodes. We could not use solution of PDOT because the pullulan is dissolvable in water. So if we had used the usual PDOT, we had destroyed the system. And the pullulan itself is realized by electrospinning with the devices that we have in our lab. And once it has been realized, you can see from the picture the difference. We have not anymore the bluish PDOT, but we have the silver on the to realize the electrodes. And we, by using the usual system, we investigated its preliminarily mechanoelectrical transduction property in the amplitude domain and in the frequency domain. This is what's happened in the neighborhood of the resonant frequency. And finally, we realized deformation. We proved that the system can work as a finite time life deformation system. This is the last part of my presentation. In the meantime, we changed the experimental setup. Now the beam is mounted in a different configuration. And if you can run this video again, no, this one, yep. You can see again the same structure, the system, the vibrating system, and on the oscilloscope screen, you will see again the applied deformation in green and the produced voltage in volts, saying you that we are changing technologies, but we are obtaining the same results. And finally, just as a final result, this is what we are working right now. No, this one, we are working on an FM multi-domain modeling of these devices. This is our newest results, where we try to understand. That system is very complex. You have charges of two different species, positive and negative charge, that move in a fluid in a porous media. And you need to model all this system. So this is what we have done so far, to show what are the contribution of the different components of current, either diffusion, migration, or advection. This is it, and I am here for curiosity or whatever.
Professor Graziani, thank you very much indeed. Grazie mille, right? So there might be some questions from the audience. We don't have much time, sir, but yes, okay.
Thank you for your presentation and for your work, because it's quite complementary what we are doing. Just something, when you try to exploit as much as you can the flows for sensing applications, why you don't exploit microfluidics with electrostatic fields where you can even
Okay, yeah, sure. Because this was considered for macroscopic application, I was thinking about drinking water, where you need to monitor ordinary devices, okay? In that case, you do not want to have anything really expensive. You want to have something very simple that maybe you even forget there forever, okay? So we want not to, let's say, modify too much this.
Yeah, I have a second question,
Sure.
sorry. Because this is my word, is the paper, exploit nanocellulose. In your membranes, we can make very thin membranes, and we could even control all the sensing applications that you mentioned there. We could exploit the membrane as a capacitor, where we have an antenna or a coil, where could be more sensing, because you can sensing the frequency and the amplitude. Why you don't are moving on this? You are just putting all your pressure on flows.
Because we are thinking about self-generating devices. The main difference is that here you produce a voltage or a current, okay? Instead of modifying a signal.
Okay, thank you very much.
Sure.
Once again. Thank you very much indeed, Professor Graziani. And ladies and gentlemen, now I would like to invite you for a coffee break, which is going to be quite short. We need to shorten that a bit. So the break is a great opportunity not only to enjoy coffee, but also to relax and also to learn about the achievements of our scholars by the stands arranged and managed by particular units at the university, which you can find in the main lobby. And right next to the catering area, which is on my right here, so on your left when you come down, you will find the PUT brand shop, where you can find, you can buy a wide range of our university souvenirs and gadgets. And please know that we kindly request everyone to arrive back in the lecture hall at 12:30. Thank you. Coffee is through that exit door on my right. Thank you. 1, 2. Right, ladies and gentlemen, before we begin, I would like to ask, is Dr. Petra Berg here? Dr. Petra Berg. So I'm afraid we cannot begin yet because Dr. Petra Berg of the University of Warsaw is our next presenter. So bear with me for a sec. Dr. Petra Berg is going to deliver a presentation on becoming richer by becoming greener, but we need to wait a little for Dr. Berg to arrive. Oh, yes, I think this is Dr. Petra Berg, right? No, apparently it is not. Now we've made a few phone calls, so we're trying to locate our scientist. Okay, so Dr. Petra Berg. Oh, yeah, okay. Finally found. That's fine, okay. So, ladies and gentlemen, welcome after the coffee break. It is now time for our next faculty. Let me now invite the Vice Dean of the Faculty of Architecture, Professor Adam Nadolny, and his guest from the University of Wasa, Dr. Petra Berg.
Okay, good afternoon, ladies and gentlemen. As you can see, I'm not a Petra Berg. I would like to just introduce our next speaker this afternoon. Dr. Petra Berg is a postdoctoral researcher at the University of Wasa School of Marketing and Communication. Her research sits at the intersections of micro-marketing, business ecosystems, energy behavior, and sustainability transitions, drawing on perspectives from marketing systems, social paradigms, circular economy, and cybersecurity, and energy system. She has a long experience as a researcher and teacher. She's also person responsible for the Teaching Sustainable Disciplinary Project by the national and European Union foundings. Petra also serves on the board of the Nordic Energy Equality Network, acts as deputy coordinator for the Finnish Climate University, and is a member of the University of Wasa Sustainability Committee. Welcome once again at PUT. The floor is yours. Welcome once again.
So, hello everybody, and sorry for being late. I got lost in this building. I'm going to try to do this without glasses, so let's see how it goes. My name is Petra, as you already heard, and I'm working as a researcher at the University of Wasa. I was given the title Becoming Richer by Becoming Greener, and I would say remember the question mark, because it's going to be doing a bit of a work during this presentation. Well, you heard my background already, so we don't really need to dive that very much. Maybe a few things to notice. I'm doing critical marketing research. I'm also looking at sustainability. And one of my favorite methodologies is discourse analysis. So very qualitative soft research. After these first three presentations, which were all about hard technology, facts, measurable stuff, and also very micro level, now we're going to be doing macro level and systems perspective instead. I've also been traveling and living abroad for the over 10 years of my life, so I've been kind of living the discourses I'm now also I'm going to be talking about in this and presenting to you. So let's start with something I think is super important, and that's conceptual clarity. What do we actually mean by green, and what do we mean by rich? Green could be something like fresh, naive. It could be fertile, nature. It can be permission, green less dollars. Green can also be sacred. It actually is something about growth, life, and vitality. Then again, rich could be thick, layered, abundant. It's actually full caloric, so it's something that gives life. And it's also wealthy. Actually, rich was more about power earlier, and now later on it's been more about the money or the having economic power still. And then the become, actually, I had to take it into here as well, because that means that we are in a state of becoming something, so we are in a process. And usually when somebody's talking about becoming, there's somebody who's maybe wanting to define what we should become. And where does it lead me? Well, of course, to the green transition and the green economy, because these are the things we are talking about, doing research about, and I'm going to have a bit of a deep dive into this. If we interpret first of all, or say what the institutional language is telling us about this green transition and the green economy. We want to phase out fossil fuels. We want to move towards renewables. We want to reduce emissions. And we want to boost circularity. We want to protect diversity and ecosystems. And we want to be just. There's something we all hear. We don't want to leave anybody behind. The green economy is kind of the end state of a good green transition, because that's where we have managed to become greener. That would be low carbon production across all sectors. That would be resource efficiency, energy, materials, land, circularity, reuse, recycling, longevity, nature positive growth, and inclusive prosperity and decent jobs. So we would become a form of richness that's rooted in ecological growth rather than exploitation. But we're kind of dealing with an institutional lock here. Green should become rich by using the green transition and green economy. The boundaries we just looked at are actually giving us a lot of conditions. They are defining what that richness can be. So we are actually subordinated to certain limits already at this point. So abundance and richness can only happen inside the framework of what we talk about in the green transition. So if we look at what we kind of agree to becoming richer in the green transition right now, it's that GDP alone won't do. Wealth is that it's concentrated more and more is a problem. We can't negotiate ecological limits, and that social justice matters. And as we can see, again, we have now a framework for what this should be. And this is something we have institutionalized because this is agreed upon EU level. This is the transition all countries are working towards. So actually, we could also define this as a wicked challenge. What is a wicked challenge? It's a systemic challenge which is very hard to grasp because it has so many loose parts. And it cannot be solved by the same tools that got us into it. This picture here has followed me since 2013 when I started to work on my PhD. Nowadays, solar, I think this guy would say, okay, solar is okay. But what's actually interesting here is what would he say now isn't feasible? And this is where I think we should maybe start paying a little bit more attention, that who is making what feasible in a transition like this. I'm going to now exemplify the wickedness of the green transition through one paradox. I call it the battery paradox. First time I had a course about that included the battery. Batteries, like I had to talk about battery to technical students was in 2018. So I was kind of looking into it from also the side of that, okay, what could be the negative effects of what we're doing right now or what we're trying to achieve? And in 2018, there was, let's say, 4 big challenges with the battery storage. It was dirty grids, scarce minerals, high costs, and fire risks. Now we're 8 years in, and there's a lot of investment been in these years. So if we look at where we are, I can actually point with it. Well, look at the 2026 there. So where are we now? We are having China controlling over 80% of the manufacturing and 90% of material processing. Lithium and nickel are replacing cobalt as the carbon footprint drivers. So they've been actually taking down the fire risk a little bit, but we're still kind of dealing with that as well. And actually the industry is on a 1 gigaton per year trajectory regarding manufacturing of these batteries still. So a lot of progress has been made, no? We have the new EU battery regulation that is already steering the market. We have the chemistry changes. The pack prices are now roughly halved. And there's new gigafactories all around the world. But still we see that actually the system keeps on producing similar effects, externalities. Back to the idea of the wicked problem here. So 7 years, trillions of euros, and the fundamental dilemma is structurally the same. So why do we produce batteries? Well, one of the things is that we want to be independent from fossils because we want to cut emissions. And we want to cut the use of rare minerals because we want to protect the planet. But still, it's kind of, we can see that this problem hasn't really disappeared now. Not yet, at least. So that makes me think, is this actually a technology problem, or do we have a problem in the way we are thinking about transition? The dominant social paradigm is a way of explaining this thinking. We use it in environmental sociology and especially macro marketing, where my research stems from. The DSP, the dominant social paradigm, is a set of assumptions of that a society runs on without actually being capable of questioning them because we are embedded in those assumptions. There are 4 main pillars for what we call dominant social paradigm, or the Western. First of all, growth orientation. So economic expansion is kind of the default of how we measure progress. Then we have what we call technological optimism. That is that we believe that innovations will always resolve environmental constraint without actually having to change structures in any way. Market faith. We believe that markets will always allocate resources effectively, including natural ones, if we don't hinder it too much. And then we have this human exceptionalism. What is that? It is the assumption that the human is somehow always capable of going beyond the natural limits, and kind of limits that might apply to other species, but not us. And this is actually the invisible operating system that we all are operating inside in our Western society. So it kind of shapes what we count as realistic solutions. And when this paradigm generates problems, like the battery paradox, it tries to address it with the same tools that actually created the problem. So more technology, more investment, more market mechanism, quicker, faster, better, and more micro, so more expertise. We want to understand each detail, and we start losing more and more sight of the system we are producing. So the structure is actually keeping on repeating itself because the thinking out beneath it is repeating. Now, if you think this is somehow connected to a debate in sustainability science, you're right. There's also something talk about a lot, and they are the definitions about weak sustainability and strong sustainability. These are actually fundamentally different ways to think about what it contains. And actually the green transition avoids making this distinction. So we're not really wanting to go there. Weak sustainability says that natural capital can be substituted by humans and human-made capital. We can replace forest with carbon capture facilities. We can continue growth. It just gets greener. And efficiency gains and circular models can decouple harm from output. So as long as we become more circular, more reuse, we can stay away from doing harm. Actually, this is where the DSP just remains untouched. If we look at what strong sustainability is saying, it's saying that you shouldn't actually touch some natural capital at all. You can't substitute it. And biodiversity, stable climate, fertile soil, they cannot be replaced by technology. And ecological limits are absolute. So the economy must operate within them, not optimize around them. And this means actually that the DSP we are living in itself has to be questioned. Sufficiency, commons, it's not just efficiency. And now the green transition, and this is my critical way of looking at the green transition, so you might agree or not, but the green transition as it is, and as it's spoken, it's very much operating inside weak sustainability. And let's keep this in mind now as we dive into the next part, which is actually the discourses. This is from my work looking at the discourses in the Finnish market from 2011 to 2025, so quite a long time. What kind of collective meaning structures do emerge there? All of these 5 I'm going to present now still operates inside the dominant social paradigm, but they occupy very different positions inside it. Maybe a quick note about the method for the ones who are not very familiar with it. Discourse is not a person, it's a collective structure of meanings that could be like a bubble above, let's say, the Finnish market. So you will have certain types of thinking about progress, for example, which together form a discourse. It's a way of explaining reality that many people carry together, and often we carry several of these at once. It's very random to find somebody who will be very much just one discourse. These are now the 5 ones I've kind of noticed in the Finnish market, and this is based upon different sets of longitudinal data. If we look at what these discourses are saying about the green transition, how they talk about this promise of progress and green richness, you have the landholder for the first. And the landholder says, my land is mine, so back off. They reject the promise. They say that they are actually becoming poorer and more dependent in what is called progress. Then we have the governor. The governor is the one governing the system. They have the expertise, they have the mandate. They actually administer the promise. So green growth is the national strategy, and that's of course managed responsibly and with the future well of everybody in sight. Then the solar punk. That's the smart and emission-free future talking. That's embodying the promise of the green transition. More technology, more innovation, more knowledge, and we can fix this. We just need to make it quicker. We just need to take away everything that holds us back. So case closed, it will happen. The only question is speed. Then there's the activist discourse. So the world is burning. There is no return to old ways. So this is actually radicalizing the promise, like this has to happen quicker. We know what we want to do, let's do it. But it's actually not capable of questioning what would be instead. So it's not capable of questioning the destination of this, let's do something quickly, let's save the world. And then we have the watcher. And the watcher says, we don't want to talk about certain things. They are actually questioning the promise. What if richer and greener have been predefined to guarantee an answer? And as I said, all of these are operating inside our common current system, so the current DSP. Even the activist and the watcher. And none of these is capable of stepping outside the paradigm to question the foundations. They argue about pace, direction, fairness, feasibility, but the operating system remains. We're going to have a bit of a deeper look at two of the discourses. First of all, the solar punk. This is the leading discourse in the energy transition when you listen to experts speaking. They say, case closed to debate that thing, it will happen, industry leaders speaking. These new operational models are coming in any case, and the one who grabs this opportunity will have the competitive advantage. So here the future is already decided. Debate around direction has collapsed into debate about speed. And if we look at it from the DSP perspective again, and sustainability framing, that this is the discourse which is also most likely to be seen as the strongest sustainability voice currently. But what it's actually reproducing is weak sustainability if we go back to the definitions. Technology as a destination, growth as the unquestionable way, natural capital as substitutable, and this is DSP running at full speed. So this is the green in wrapping. Then let's look at the watcher. The watcher is the weakest discourse. People who gather inside this discourse say it is very difficult to have this debate. I already feel saying this out like, let's not go there. I wouldn't like to discuss this, but we have to. Could we organize society in a different way that doesn't follow the growth model, that looks at the ecological processes more and aligns our lives with the web of life, that we are part of ourselves? If you look at the first quote, it actually shows you the cost of watching. It shows you the cost of questioning something which is in the system you live in and where you are totally embedded and trying to express something about that. There's also the question of seeing what others don't see. The watcher is closest to articulating strong sustainability, but the larger discursive field has no room for it. It can be felt, but it cannot be built with. Now, if we go into today's world, these 5 discourses have been quite happily coexisting and challenging each other for the last over 10 years. I've been looking at them. The watcher has maybe grown a bit stronger, but they have this kind of a dysfunctional equilibrium in the Finnish market. But what happens when the material basis of the promise is suddenly in question? That's what we're living right now. The Strait of Hormuz. What if the material basis breaks? Let's test these 5 discourses. This is something that we're actually living through as we speak. And bear with me, these are probably not the correct number and hopefully not exactly what's going to be, but I'm playing around with scenarios here. Since March, we have the crisis in Hormuz. Let's use it as a stress test. What happens with these discourses when the material conditions are no longer maintaining anything we're used to? The acute, what we're dealing now with, supply shock, price spikes, at least 20% of Europe's oil already. Prices past $120 a barrel. The gas storages in the EU are at 30% or even lower. We're talking about the International Energy Agency actually calling this the greatest energy security challenge in history. Well, here, the governor will take responsibility. They will command, they will raise taxes, they will say they know what to do. The activists are going to demand action, and maybe the landholder is still resilient. if we look at what could be coming in the next years, 1 to 3 years, that's when the cascades start setting in. So the actual repercussions of what we are living now, which would, for example, be the fertilizer cascade. Here, that would be the sowing shortfalls we're already dealing with. This is where the Finnish farmers, for example, are now discussing already what to sow next spring. So this is already kind of happening. Here, the solar punk is probably still able to reassert and say, let's just get greener faster. The landholder is probably getting a little bit more credibility because they are the ones maintaining us with food. But at the same time, the energy poverty deepens. And this is also something we're dealing with already. Now let's look at the structural, so 5 to 15 years. Maybe they have, by the 5 years now, been able to fix Qatar's largest LNG factory or facility because that was damaged. That means that will start working again in the next 5 years, maybe. But a lot of our supply chains are now, and maybe still then, through those choke points. And depending a little bit now how things go now, the next 5 years will show where we are at that stage. But I think this is where we actually start listening to the watcher. Because this is when the watcher's questions, which are too uncomfortable for us right now, because they are questioning what we are actually doing, they might start making sense, and we might want to look into that. And this is also where we start noticing that the DSP has limits. What do I mean with all of this? Why do I take such a weird example and such a political example here? I want to ask which of these discourses holds the acute, the cascading, and the systemic. If the governor handles weeks or this year, the solar punk handles the coming years, the landholder might handle keeping us with food, the activist is still in urgency, and the watcher sees but cannot build with it. There's nobody who's actually handling this, the entire picture, none of these discourses. So the voice that would see the supply shock, the fertilizer cascade, and the structural dependency as one integrated challenge does not exist in the institutional discourses we hear today. And I have named this the absent myth. And now, if you remember what we were talking about, the DSP, you can also see why it's absent, because it doesn't fit in to what our direction is, or how we tend to think about our green transition and progress. So the paradigm kind of excludes new thinking. It excludes questions that are too big for it to answer. The absent myth is a strong sustainability position. There are maybe more, but let me give 2 examples of what is getting excluded right now. This A could be tolerable because it's a little bit what we are already working with. Sufficiency, commons, shared resourcefulness, that's partially visible. It can be discussed, it could be co-opted, it could start serving our system. It's conscious consumption or circular economy. But how does it look when the material basis is challenged? It actually looks like the end consumer who's fighting to heat their house and cannot afford the bills. And they are told that they are responsible for the sustainability. So this is once again the weak sustainability that's stressing as strong. But this is still something we might be able to, tolerate. But then there's actually something called material sovereignty and productive autonomy. That's the farmer who's heating their house with wood and growing their own ecological food. They are materially resilient. but they are not green in any metrics that the transition requires. Today, for example, in Finland, the government is actually discussing whether we should totally cut subsidies from small unproductive farms, because we want to consolidate towards bigger, more controllable units. And this is not farms, this is everything, energy and so on. This is actually a genuinely strong sustainability position, and it's very much challenged and not seen as such. And the interesting thing here behind it is not that somebody would actually think it's bad. Actually, when we think about it, it's logical that we see that the bottom-up movement is something we really need. But when we look at how the structures of the green transitions are now formed, they are not giving space to the bottom-up. They are actually very much top-down. So what is the mechanism here? Giddens talks about ontological security. Marcus is talking about surplus repression. And we had Gramsci talking about the hegemony, which all means that the system is always trying to maintain its status quo. And when we return to the title and the question, becoming richer by becoming greener, I think we're not dealing with a question of the green transition delivering prosperity and richness in itself. It's more about how we actually define green and rich, and what do we permit to exist. And do we pay attention to what is excluded before it's too late? So the deeper question behind this is that, can the transition, which is built entirely within weak sustainability, within the dominant social paradigm of our day, actually produce the strong sustainability or situation that we are saying we should, and that we would require right now? So it's not whether it's succeeding, because I'm sure it is succeeding at some point, but what kind of system is it succeeding to reproduce? So yeah, thank you.
1, 2, 1. Thank you, Dr. Berg, for a very interesting talk. So there might be some questions here. Oh, there is a question here.
Thank you very much for your social dimension to see science. I have just some curiosities in your talk. First of all, you are living in a different world where people want welfare and comfort. So, is the progress impacting that we have to return, or shall we try to find the science and technology able to keep comfort and welfare to the people? Because this is a decision that we have to take. What is the best for our progress? Is stop everything and go back, or try to think how science can impact on our development? This is my first question. The second is about sustainability. The term sustainability means different things. In energy, in manufacturing, and we cannot say that sustainability is the same. It's not. Because in energy, for instance, it means long lifetimes for what I'm working with. If I go for manufacturing, is how this could go on circularity and so on. And also sustainability for society is different. For me, means the goals that makes, because we are making progress in the name of the people and for the people. You said Marcus said this several times in the past. And the third is the following. What do you think should be the rules that we, as a global not just European, but a global society should look in terms of the transition, because transition is too vague as we are defining. What is really we have to face, because we are 8.15 billion people, not 300 million Europeans. How you think we should try to move?
Okay, do we have an hour? No, okay, very quickly. Yes. The first question was about defining progress. And I think we have to stay away from polarities, because when we start talking, it's either that we get wealthier and better, or we have to go back. I don't think it's either or, I think it's the middle way. And this is why I think it's super important that we make more space for the so-called watcher discourse, because they probably have what we don't allow or see when we are planning things right now. We are humans, so we usually build our boom boxes. We want to have like-minded ones making decisions and thinking about things together. So it comes very much also to diversity, but diversity on a paradigmal level, which is actually different from just diversity in specialization. So maybe this answers all three questions. Quickly, it's like I see the paradigm like that we have a train track. And right now we are trying to solve all the troubles by building new trains, but we are building them to the same track. And what we would need to somehow find out is how do we actually make a new track that takes us somewhere else or something else. And globally, I think the only medicine to the troubles we are seeing globally is that we have to become sustainable locally. And that has also to do with Elinor Ostrom's 10 rules about what makes a sustainable economy. And by knowing what we are doing in our backyard, we can have a better take on what others are doing in their backyards. But right now we tend to focus on macro scale, and we tend to focus on big investments, and we are actually not looking at the small investments and the local investments, which might be the route to local sustainability. And I don't know if I answered everything, but we can talk about this later. Thank you.
Thank you very much once again. Moving on. I would now like to invite the Dean of the Faculty of Environmental Engineering and Energy, Professor Zbigniew Nadolny, and his guest from the University of Cantabria, Professor Maria Margallo.
Good afternoon, everybody. Professor Maria Margallo from University of Cantabria is a chemical engineering and holds a PhD in chemical engineering, awarded the Extraordinary Doctorate Prize at the University of Cantabria. Her research work in the Department of Chemical and Biomolecular Engineering has focused on the use of life cycle assessment as a tool of evaluate the environmental impact of a wide variety of process, products, and services, covering areas such as waste management, food, tourist, and the chemical and metallurgical industries. She has participated in around 45 research projects, both national and international, as well as collaborating on contracts with companies and public entities. This work has resulted in the publication of 128 papers in high-impact journal, like Index of 33, several book chapters, and participation in around 180 international conferences, where she has also contributed to the organization and to technical and scientific committees. In the academic field, she has supervised 5 doctoral theses and currently is supervising 2 ongoing ones. In 2016, she began her teaching careers after obtaining a position of assistant professor, which she consolidated this year, 2026, when she became associate professor. Her teaching activity has mainly focused on the bachelor's degree in chemical engineering and the inter-university master degree, chemical engineering, with notable involvement in courses related to environmental sustainability in the industrial sector. She currently also teaches at the School of Mining and Energy Engineering. In terms of academic management, she is the secretary of the Quality Committee of the Master's degree in Chemical Engineering at the University of Cambria and has been responsible for several venues of the summer courses of the university, and since 2025, she is a vice rector for sustainability and activities. Professor, the desk is yours.
Dzień dobry. This is the only word I'm going to say in Polish, but okay. So, good morning, all of you, and thank you for being here. I will continue with these soft skills of sustainability. I would like to go in a journey with all of you, a holistic journey from Brundtland report to the current Green Deal. So I will start with the myth of unlimited growth. I will continue with this journey of sustainability. And, well, I'm going to talk to you about the application of life cycle assessment to sustainability. So we will continue with the previous talk, and we will continue with this concept of green market and eco-labels. So this is the first problem that we have, the pre-environmental area. There was a myth of unlimited growth. All of you know that. And why we have this problem? This problem was because there was a myth that we have an unlimited resource availability. This was not true. And also that there was unlimited assimilation capacity. So we can use all the natural resource that we want. This was the idea. And the planet was able to absorb all the waste and all the emission that we were doing. The first warning was very, very long time ago with this essay of the principle of population. This was done by the first demographer, that was Robert Malthus, which was this essay. This essay said that there was a problem between the population growth and the resource growth. There was not the same trend. We have geometrical growth of population, while we have arithmetical growth of resources. This is the actual or the current pressure and the current tension that we have in sustainability. This is something that is still something that is able. No? This was the first problem that we find, and what happened later? We have the Industrial Revolution, but we have also the end of this industrial dream. The dream was that we were able to use all the resources, but we were starting to find some problems. So we have the first report of the Club of Rome, and we have the first Earth Summit in Stockholm. Here we will continue with this concept, the limits of growth. If growth continue with this, if population continue with this growth, the physical planet of the physical limit of the planet will be reached in a century. This is the second warning. Remember that we have the first more than 200 years ago, and we will continue with this problem. In this first Herr Submit, all these concepts were put or were made visible to all society. After this second warning, we have a series of disasters in the industrial in the industry. One of them was the Love Canal in the United States. This is a very very not nice. It was a disaster, but we have this name of love, and at the end we have a nightmare. Why? Because they built a neighborhood inside a landfill, and at the end there was a toxic place where people were living. So we have this disaster, and after that we have the Seveso disaster that all of you know about that, and now we have a specific directive about this topic, about safety. And after that we will continue with some nuclear disaster like the 3 Mile Island. Of course, we have Chernobyl, and we have the Bhopal accident in India. This was one of the highest accidents that we have in a chemical plant. So all these disasters made that our regulation were stricter in terms of environmental aspect. So remember the first warning, the second warning, all these disasters. What we are going to do? Well, we continue by the 80s. In the 80s, we have the Brundtland report. So we have started the journey from 200 years ago, and in this date, we have this report where the first definition of sustainable development appears. What means sustainable development? All of you know that this means that it's a development that meets the needs of the present without compromising the ability of future of the next generation. This was a very important date, and it was the first time that we link environment with economic and social aspect. This is the beginning of the concept sustainability. Later, we talk more about what is sustainability. We have been, we were in the previous talk, the different types of sustainability, weak, strong, and stronger sustainability, but all of them are based in 3 main pillars. Okay, let's continue with the journey. We have the next Submit, Herr Submit, that we are in Rio, Johannesburg, and again in Rio. In all these Submit, we have some evolution in the concept of sustainability, and one of them are the Sustainable Development Goals. Previously, we have the Millennium Development Goals, and this is important that we move from 8 goals to the 17 goals that we have now in the Sustainable Development Goals. So nowadays in Europe we have a new, a new deal that is the European Green Deal. So nowadays this is our roadmap. Our roadmap was done in 2019, and we continue with the strategy of decoupling economic development with the resource use. The main goal of this deal is to have a neutral Europe in 2015, and the second, that no people or place must be left behind. This is something important that is included also in the Sustainable Development Goals, where people and society are included. Okay, we have this deal, but let's go to the reality. Let's check what is the situation. First, we have achieved a reduction of greenhouse gases. This is something good. We are working in the right way. The current status, we have some targets that are on track. Some of them need acceleration, but we are off track in 15 of them. So what are the main challenges? The main challenges is that we are going to, are we going to reach this target? We are close today. In this Green Deal, we have some important aspects. Which aspects? So we have energy, we have transport, buildings, and industry. Why? Because they are the four main contributors to greenhouse gas emission. You can see that energy and transport are the most pollutant sectors in this aspect. So we have made this journey between all the regulation, all the submit, but what is sustainability? We were talking about the pillars. We have, this is a chair that have 3 legs. So if one of them is not in the balance, the chair will be broken. So this is important. We have different types of sustainability. We have this weak sustainability, a strong sustainability, a stronger sustainability. We have some sustainability that have more, that consider more the economic aspect, others that consider more the environmental aspect. But the idea is to have this balance, to have this idea of sustainable development. So let's move now to all this philosophy to the empirical data. How can we measure sustainability? We have to use environmental tools. These environmental tools will help us to quantify the environmental impact and to get more sustainable processes and services. But this tool need to provide quantified environmental, social, and economic aspect, need to have a dynamic idea, a long-term dynamic impact, and also has to apply transparent method that help decision-making. We have different tools, we have risk assessment, we have cost-benefit analysis, but today I'm going to talk to you about life cycle assessment. So the first study of life cycle assessment it was not called life cycle assessment in this period, it was called resource environmental profile analysis, was done for the company Coca-Cola. This is a very important study because we have to take into account that in that period, well, nowadays again, plastic had a bad reputation. Also, we have to consider that in this period we have some of the most important oil crises. Today also, so we are again in the same situation more or less. Well, this study wants to compare different type of packaging. It wants to compare plastic versus glass, and the study have a surprising result. The best option was the plastic packaging. As I said, this was the first study that was done for the company Coca-Cola, and after that, the studies continues evaluating different type of packaging, evaluating waste treatment, industrial processes, different type of food sectors. And why I am making this journey about life cycle assessment? Because it's important that we see that it was also in the late 16 and the beginning of the 17 when we start to get more concerned about the environmental impact of our life. So just a brief overview of what is life cycle assessment. Life cycle assessment is a holistic tool that is used to identify the inputs, outputs, and environmental impact of a process, product, or service. And it's important to know that this is something that goes from the cradle to grave, from raw material extraction, production, transport, and to the end of life of the product. As I say, this methodology started in the 17th, without any type of standardized methodology. It was something that was used without any type of standard, but nowadays we have a standardized methodology that comprise 4 main steps. One of them is one of the most important is the goal and scope. We have to define what is going to be included in our study, which is the scope of our study, the limits of our study. Once we have that, we have to compile all our input and output data, and they are going to be later translated in an environmental indicator. Of course, we have later the interpretation of the result. Okay, this is the methodology I'm going to explain you later with some small case studies. What is the use of life cycle assessment? Because it's common that everybody includes some life cycle assessment in their projects, in their teaching, but it's important to know which is the methodology and which are the applications. We can use it in the different levels. We have a corporate level, something internal of the company, and we have something more external at the market level that was more or less the previous talk, no? About the external use of environmental tools or discursive tools. So at internal level is important because we can take or we can evaluate the hotspot of our system. We can know where we have the main environmental problems, and of course, environmental problems means economic cost, okay? Because if we have some environmental problem related with energy consumption, at the end, we will have some economic cost. This evolution or this known of our hotspots allow to optimize our system and, of course, to pursue sustainable targets to improve later our system. At the market level, we can identify the market choice, we can impact on consumer choice, but we can influence also in regulation and legislative actions. Okay? So, but all these tools are very important. We will have a scientific tool, but there is a problem because we need to communicate all this information to consumer. How can we communicate life cycle assessment result to consumers? One way is the use of eco-labels. Eco-labels are nowadays also, or have now also a standard, an ISO standard. And the goal, of course, is to stimulate the continuous market-driven environmental improvement. This is one of the goals, but the other is also to promote the demand of these environmental-friendly products and services. How can we reach these goals? First, to communicate the information, we need to communicate good information, precise information, and in a very visual way. And we have to avoid confusion and greenwashing. If I ask you, all of you, who knows one eco-label, can you stamp up your hands? Who knows one eco-label, ecological eco-label? Yes? Okay, but do you know what mean the information that you have in the eco-labels? We have a lot of eco-labels. Consumers do not know what is the information that this label wants to say. So we have 3 types of eco-labels, type 1, 2, and 3. This is easy, 1, 2, and 3. And the mechanisms, the verification, and the type of information behind all of them is different, but also the type of information or the type of final consumer is different. So we have type 1. Type 1 is based on life cycle assessment, is based on a standardized methodology. One thing is that all of them are voluntary, and it needs a third-part verification. So one of them, you can see here, you have the European Eco Label, you have the Blue Angel, so I am sure that all of you have seen this information in the supermarket or wherever you go. The second type of eco labels is a self-declared claims that is made by the manufacturer. This means this is not a good information? No, this means that we don't have this third-party verification. So sometimes they can have some problems with greenwashing and some type of claims that are not appropriate, like green, sustainable. I think that all of you, when you go to the supermarket, you see this type of information. No? The more sustainable, the more green. And this is an example, it's in Spanish, but you can see in the green part, well, one of the things is that it is using now the green. The green is not very appropriate because you go to the green and you can think that it is better. And the name, the new packaging, more sustainable. Okay, this is a type of greenwashing because we don't see what information is behind this study, and the less use of plastic. Also, you have another label that is the nutritional score in the bottom of the packaging. So second type without any type of verification, and we have the third type, is the environmental product declaration. This is based on a whole life cycle assessment. You can go to the EPD and you will find the complete report of the product. But do you think this is something that you can read when you go to supermarket? You can go and you can read 3 pages to decide what you want. This is not for consumers, okay? For consumers, we will use type 1 or type 2 because they are more visual. So now I will explain you after this more theoretical part how we can go ahead with our project. So we were working in the food sector. We were working in the seafood. And, well, we think that there was not a lot of information about the environmental practice in this type of sector. So we have the project Neptunus that was an Interreg project. It's already finished. And the mission of this project was to promote sustainable development in the Atlantic area. What we want was to, to have an environmental tool and an environmental label to provide all this information to consumers. I will tell you later the results of that. Also, we want to develop circular economy strategies, both in the technical part, this meaning the packaging, and in the biological cycle. So we were working in food waste. We were working in improving the packaging, but the main core of the project was the application of life cycle assessment. The idea was to compile life cycle inventories to get input and output data from different species in the Atlantic area to provide life cycle assessment results. And we were thinking, how can we provide all this information to consumers? Because at the end, this was the idea. So we were working during more than 1 year, collecting all this data for more than 50 fishing activities. And we model these life cycle inventories. At the end, we get the carbon footprint, the energy footprint, the water footprint. Why? Because we decided these were the most important environmental indicators. But also, we want to determine the nutritional footprint. Why? Because it is important to provide that information to consumers. Okay, we have a fish with an environmental impact, but you have a product with a high nutritional content. Okay? If we provide all this information to consumers, the carbon, the energy, the water, the nutritional, how can decide which is the best option? So at the end, what we decided was to use a normalized and weighting procedures to get a nexus indicator. And this was the final label that we decided to use. It was a label that combines the 4 environmental indicators, and we give a color from red to 4. This is not something new. I know that this color are used in many eco-labels, but this provides to consumer a scientific information in an easier way. Well, the other thing that we make in this project was the development of a tool that was used or could be used for consumers, but also for producers. And the profile was different because at the end, the results for both of them has to be different. This is free in our website, and everybody can use it. So you have it's an Excel file. You can introduce all your data, and at the end, you will get this information that I showed you before. But what happened at the end? This was in our lab, this was in our office, but when we go to the consumers, what was the consumer behavior? Well, we try to put these labels in our supermarket. The consumers scan the code, and they can see this label with the final value. I don't know. With the final value, but also all the environmental information, the scientific information that was behind that label. What more they find? They find also information about how can they help to improve the environmental performance, how can they reduce the environmental impact. So it was a simple label, but also they have all the information if they want to know more. Okay, this was at the end of the project, and the project was finished. So we think, this is what we want to have? No, we need to go one step further. And we have a new project that is called Smart for C. In this project, we want to see the consumer behavior because it was something that we don't have time in the previous one. But as I say, we want to have, or we want to go a step further with the traceability system. So the idea is to combat fraud, to have an idea about the environmental impact, but for that we need a quadruple helix approach. This is a new project with 10 partners of 4 Atlantic countries, and it's based on 3 pillars. The first one is traceability. We are using blockchains. The second one is the authenticity, because we need to ensure that the label includes the true information about the species, about the origin, about the production method. This is very important in the seafood sector. But also it's important to avoid this confusion about and this green washing for the consumers. What we are going to use? Again, we use life cycle assessment to model all this information. But what is more important is what we are developing a blockchain infrastructure. We are getting data from the fishing activity, from the ports, distribution, and processing. Remember that life cycle assessment was a holistic tool, so we take into account all the food supply chain. We are with this blockchain infrastructure now, and we hope to have at the end of the project a tool more flexible that helps the consumer to get the environmental footprint again, but also something very important, the plastic footprint. This is something that usually we don't have in our products, and also the waste footprint. So the conclusion that we can have after this talk is that we have the past. In the past, we have an illusion, the illusion of unlimited resource. There was a blind extraction without impact measurement. This was the past. But the future said that this is not real. The real is that we need to have limits in our consumption, that digital transparency and circular economy are very important, and that the consumer has to be an auditor through real-time data. So how can we reach the goals of the Green Deal? We need not only this international treaty, not only regulation. We depend on technological interventions. We need people working on sustainability. We need an evolution in this field, because sustainability is not only saying, it's providing. Thank you.
Hello? Working? Okay, thank you. We have time for one question, so would anyone like to ask a question from the audience? Okay.
Your presentation is outstanding, and you can see what are the bases and what are our progress. In one of your slides, you said that you have, when you go to look for sustainability, we have also to look for the business plan. How this will impact on the strategy of the producers and manufacturers for the future? The business plan, you said in one of your slides that we have to look also for the business. How this will impact on your strategy of circularity?
I think that for the strategy, it is important for to have sustainability, to have all this information, because at the end you will get in a greener market. In my experience, all the companies that are interested in the calculation of carbon footprint and other type of indicators, they are having pressure to have all this environmental information to be introduced in the market for the supplier in the whole supply chain. So I think sustainability is being a pillar. A real environmental sustainability is a real pillar in most of the companies, because without this type of evolution, they are out of the market. So if you are out of the market, you don't have a business plan.
Once again, thank you very much, Professor Margallo. And moving on, let me now invite the Dean of the Faculty of Engineering Management, Professor Marcin Butlewski, and his guest from Brandenburg University of Technology, Cottbus, Senftenberg, Professor Silke Michalk.
Hello, ladies and gentlemen. I would like to say, good afternoon even. Professor Silke Michalk is our guest, but I wanted to say that two previous guests was also very similar to aspects which we are dealing at the Faculty of Engineering Management, and actually we could say that our risk management or or life cycle assessment is in our domain, so we are very happy that all these guests are always referring to engineering management. So our guest is Professor Michalk. Professor Silke Michalk is professor at the Brandenburg University of Technology, Cottbus, Senftenberg in Germany. He works in the field of business administration, human resource management, and general management. She started her academic career at the University of Bremen. Later, she worked at the University of Federal Armed Forces in Hamburg. Now, this university is known as Helmut Schmidt University. In 2004, she received her PhD. Her doctoral thesis focused on organization development of medium-sized companies, on the extent how consultant can support the successful change of these companies. Her research and teach focus was on human resource management, organization development, leadership, work-life balance, occupational health, demographic change, and lifelong learning. We also are very happy because of that work-life balance aspect, because this is also that what we are teaching, we are researching, but nobody from us has ever seen it. So Professor Michal's work includes books and articles on modern human resource management, work-life balance, employee performance, leadership, innovation, and intellectual capital. So all the managerial stuff over here is included. Besides her research on teaching, she serves also as the Vice Dean of Faculty. And since 2005, she is also Academic Director of the Center of Academic Continuing Education at BTU. She also serves as a visiting professor in many universities, China, South Africa, St. Petersburg, so all around the world. So please join me in warmly welcoming Professor Silke Michalk.
Thank you. Welcome this afternoon. I would like to talk about the role of human resources in management and demographic changes. I think that's a topic that is important for all of us because we are living in changes. Heard about it, but it's also demographic changes. So demographic means the people are changing. We have more old people, not enough young people perhaps. The cultural situation is changing. So we have to think about what do we do. And here we are looking especially at the workforce. We are not looking at, we are all getting older, so perhaps we need more support because we are getting ill, like work-life balance and well-being. But here we are looking more, how do we manage in the companies that we have at the right time, right amount of people with the right amount of qualification, and that's the main problem a lot of companies in the whole world or here in Europe have, and that's what we are talking about now. So just short introduction you heard, we will talk about what is the demographic change. Second, we will discuss the analysis of a major HR-related challenges resulting in these developments. And then I will present some strategies. How do companies deal with these challenges? And I will give some examples with case studies, best practices, and then we can look at what do we have to do in the future to deal with these challenges. So let me just give you a little bit more introduction. What do we have to do? So we have in Europe main factors. We have an aging population. We are all getting older. And on the other side, there are not enough children coming. So that's why we are getting older. And we have an aging population. And that also means that we have a shrinking share of working age individuals. So we have less people that are in an age where we are working in companies, in organizations. And that makes it a little bit difficult for us because we have limited resources in the companies. We talked about in the last presentation here, we talked about sustainability. And for companies, it's also a factor in terms of sustainability that I'm able to do the work that I can sell, that I can offer to people, to customers. But if I do not have a workforce to do the work, I have a problem. I will not be successful. So it's a very important resource we have in the company, the workforce. And that means we have to look how to deal with it and how to manage these workforce. And that also means we have to think about how do we attract talents in this highly competitive market of labor, because there are a lot of companies that want to have the one employer that's possible to get. So I have to offer something. Then we have another problem, because as we are changing in the world, we have more multi-generation workforces. So we have very young people working, middle-sized, and we have a lot of old people still working. So we have to think, how do we combine them? How do we manage that they are working together? And that also means that we have to build something like an inclusive organizational culture, so that we do not see, okay, we only want to have that type of person working here, but we have different old, young, male, female, from different cultures, because we need them. And why we have to do it? Just a little bit, we have differences in Europe. So here we have Germany, we are shrinking. Very much shrinking. While the Scandinavian people, they are growing. So it's not that we can say all the countries are the same. That makes it also very difficult to say, okay, that idea fits all. Because we have to look, we have different problems in different countries as well. So at the moment, in most of the countries, we have a very, actually, we are too old. But in some areas, we are also, especially here, you see that we are, we have real problems in these countries. Because that means if you have less people working, you are not as productive. You can say, okay, but now we have technology, digitalization, and so on, but it only works in certain parts, but not in all. So we still have to think about what do we have to be attractive for employees. So that is here that we have to look. And at the moment, this shrinking is also because all the baby boomers. So in the 50s, 60s, we had a lot of babies, a lot of people coming, but now they are all retiring. So they are still there, but they are not working. And of course, that's a problem, because there are not so many young people coming after them. So we have to look at it. And still, it's in the whole of Europe, we are not able to replace the amount of people we were there in our own. You can say, if you want to have the same level of people living in a country, you need 2.1, 2.2 babies per woman. At the moment, the average is 1.3, so we are just declining. At the moment, the declining is not that bad as it should be, because we have a lot of immigration coming from other countries in our countries. So we are still in a high level, but without immigrants in many countries, they will not be successful in businesses. So that's something we have to look at as well. So that's why we have a labor shortage across Europe. Just try to showcase in different European countries and to show that we do not have in all the countries problems. For instance, here we have in Finland. Okay, we have an aging population there, so it's growing. No immigration, so not much coming and brain drain, because brain drain means we have well-educated people in the country, but they decide, I want to live and work somewhere else. So that's also a problem that we have in different countries. For instance, Poland, we have the same problem that we have a lot of immigration. Nowadays, it's much declining, but in the millennium 2000 and so on, we had a big problem when Poland became member of the United European Union. A lot of people moved to other countries because they were able to earn more money there. The same problem we had in Germany with Eastern Germany. After the border, they all moved to the western parts because they could earn more money and there were more jobs. So we have very often a regional problem as well that we have to address. So, and here you can see nearly all the countries have problems to get enough trained, educated people in the area of care. That means doctors, nurses, but also caregivers for old people, for handicapped people. That's a real problem. Then other countries, depending on, some have more in engineering, IT, some in tourism, depending on what's important. So we cannot say, okay, we do one thing and that fits all. So we have to look here as well what we can do about it. So if we are looking now, what does it have? We have a workforce shrink. And we have shortages. So have limited talents, people that have the right education, the right training, the right competences that I need in my company or in my institution. But it's not only that we have a limited amount of people, it's also that we very often have a problem with the skills. So we have, it does not mean that, okay, we do not have anyone wants to work, but they have the wrong education, the wrong training. So we have a skill mismatch and gaps there. So we need to train in the jobs that we need nowadays. But if we do not have them, we can still have an amount of unemployed people, but we cannot use them in our companies because they do not have the right skills. So it's also very much about training and development people so that they can fit the new demands on working conditions as well. And what we also have in a lot of countries is the increased cultural diversity. We have more migration, cross-border flows, workforce composition, the workplaces become more multicultural. Just can say an example. I'm from Cottbus. We have a big hospital in Cottbus. At that hospital, more than 40% of the doctors working in that hospital are not born in Germany. So that's what I mean with migration. Because we need people from other countries, otherwise this hospital would not work. It's not that we have German doctors born in Germany also that are unemployed because they cannot find, because a foreigner is taking their job. We have a real lack in doctors, for example, because where we also have a problem with the baby boomers, they are all retiring. But we have to deal with it in the company. Because if I have people with a different cultural background, I have to integrate them. Perhaps they have to learn better than they are able now. That's also something we have to address. And we have, so what do we have? We have talent guarantee. That's I already said. We have people that we do not have enough good trained people. Because of a lot of people are retired, also have sometimes a problem with a knowledge transfer and succession. So I have a lot in my head. I know a lot about the company, about the jobs I did there, about how everything is worth, and tomorrow I'm retiring. I'm leaving the company. All my knowledge is here, but not in the company. So also we have to think about how do we deal with the knowledge transfer, so that the knowledge that is in the people is also accessible by their colleagues, by their successors, so that we do not always have to start at zero, but build on the knowledge that is already created. That's also here our age diversity management. We have to look at different generations. At the moment, if you look, we have up to 5 generations. The companies working. Or one just from the school of 60, it is 67. Okay, in Germany we have to work nowadays until 7. I know in other countries you can retire earlier, but that means we have a real big gap in the ages. And that also means different ideas, different perspectives, and that can cause conflict as well. So we have to think about that. How do we manage to have the older workers longer so that they do not leave early? At the moment in Germany, we also have a program that after you retire, so with 67 or so, you are able to work in the company and you do not have to pay taxes, just to address the problems we have there and to give some advantages if people stay longer than they have to work there. And we also have a problem with our technologies, new skills. So it's not enough, okay, I'm entering the company, I know what I do, and then for 20 years. That does not work. We all know we have to learn new things, but that also means we have to organize it, how to upskill and reskilling, how to address, we have to analyze which competences, what skills, who has these skills, so that we address it properly to the people who need it. Okay, I also had something, for instance, what you can do if you are talking about, okay, I do not have enough people, recruitment. It's not enough to put an advert in a newspaper to say, hey, I want to hire someone. You have to address the people. Very often we are talking about reverse recruitment. I, as a company, have to apply at my future employees. I have to know, what do they really want? What can I offer them that they come to me and not to my competitor? Because we are fighting for we do not have enough. At the moment, we have in Germany, it's I can say a little bit like capitalism. The bigger companies, they get the employees, but the smaller ones, they are without the people. Because if I have a small company, perhaps I'm not so very successful, so I do not have so much to offer, but when a big company comes and says, okay, you will get a little bit more money, you will get more holidays, and so the people moving to the bigger one. And that's a real problem for our small and medium. So we have to think about what can they offer. Perhaps they cannot increase the wages, but perhaps they have something else that they just have to market, that they have other advantages combined to the bigger company. So the knowledge transfer I talked about, you have to organize this, you have to structure it. In the organization, how do you do something like that? And the best thing, of course, is if you're working in teams, you are exchanging your knowledge, that's the best. And sometimes it's also good if you document something. If you have it somewhere in written, for the others, and that's not only if someone is leaving for longer, but that's of course also if someone is on holiday and nobody was, what do I have to do with this process? Because he is the only one who knows it. So if you do a proper documentation, it will also help. Age diversity. Think about age diversity management does not mean, oh, we are looking only at the old people. What do we do with them? Age diversity management starts with, because I have to think about, to offer something that's relevant for the different. Here in a life circle, perhaps when I'm starting working, I want to work a lot, do a lot because I want to go somewhere in the career. Then perhaps one day I will have children. I want to have a little bit more time with my children, not working much. Later, 15 years later, okay, the children are sick, I have more time. I want to do something new, perhaps. So, yeah, in the different age groups, perhaps we have different demands, what we want from our employees. And that's also what we can look here, that, for instance, not okay, you start here and then you have to go there, but that we can change it. What we have talking here, flexible working options, health and wellness support, and that's also not only for the old ones. We still have this, not with the young ones, so that they are not going like that later. So that's also something we have to take in consideration. Not only looking if something is bad, but prevention to start with all the action so that the people are able to stay their whole working life in our company. And that's also of older workers, depending on what they are working. We have some jobs that are more physical, give some physical problems. So you also can look, okay, what can that the people are able to work there and not that they have health issues concerning their work. And that is also good for the young ones, because then they are able to work the same job for longer. So we have to do their ergonomic workplace assessments, for instance. There are some quite easy that are not so expensive, but also mental and physical health support. During the last decades, we have an increasing amount of sickness leave because of mental health problems. Not only with the old, but the young ones as well. So we have to look at that as well, what can we offer organization support our employees in this part as well. It's not only that I give them some courses how to help your back, but also how to help your brain perhaps. And we talked about the upskilling and training initiative, that it's not something special, some training, but we are more in a lifelong learning process, and we have to offer it. It's not, as it perhaps was funny, okay, you need to learn something, go for a seminar or so, but we also have to have options. How can you learn while being in the workplace? What conditions can we offer that you can learning by doing and so on? So we have a lot of possibilities there as well. I also talked already talked about our age management, because at the moment that's our biggest focus, because we have a lot of people working in the companies that are older, retiring in the next years, but we want to have them as long as possible, so that they are not leaving with 60, but with 7 longer. And there we have to look what we can do, but we also have to keep in mind, if we want to employ someone, think about how long will he be in the company. In the past, we often thought about, okay, someone is 50, oh, that's too old. We are looking for a younger person. But in Germany, that means if one person with 50 is still 70 years in your company. So that's a long time. So we have to think about when is a person too old to be employed? And is it not better to have someone for 5-6 years and have nothing? And it's also the problem if young person, you employ a young one, does this person stays his or her whole life in my company? So you never know how long they will stay. So also you can employ old ones as well. The others we also had about them and diversity. Just as an example in Germany, a lot of people also say, oh, we do not want to have foreigners based jobs, but if you look at it, I gave the example with the hospital in Cottbus. Without the foreigners, the economic would break. At the moment, we thought here in other countries they have problems with hospitality as well. Do not have someone who wants to work at night in a restaurant. So Germans want to have other jobs also. So we need some people who want to do it. Okay, I'm from Cottbus, that's really near the Polish border. So we have a lot of people from Poland working in Cottbus in different jobs, living then in Cottbus or just commuting because it's just 20 minutes border. Without these people, work because we do not have a high unemployment rate, and the people that are unemployed are not do not fit the job spec. So we have to look what do we do and how can we improve it, and especially in the care sector we need a lot of people because we do not have enough. But when we have to train them how to and so on, but also have to integrate them in our countries, that they do not say, okay, not nice, I want to go home in my home country. That's what some companies, Accor, that's a French group, and it's a hospitality group, so they have a lot of hotels. They are looking structured onboarding programs for refugees, because they also have a problem. I do not get enough people working in the hospitality sector, language support and so on to get the people. Bosch has a big program, life phase oriented HRM. So they have health programs. They do a lot that the people are able to work till they retire. BMW, because they are also very much in the production area, they changed their production lines so that people are working in healthier environment, more support so that they do not get health issues while working there. But robotics implemented blind recruiting, because very often you have a problem. You get some applications for a job, then you look at the photo, that looks nice, but not so, okay, put it away, or this is a name that looks a little bit strange, I take the other one. And with blind recruiting, you only see the qualification of a person, but not which nationality, what gender, what age, how they look. So you really do an objective looking at the people, and only later on you see, okay, is it? And they were very successful with it, because when you get a much more diverse workforce than you before. SAP focused on a special group of people with autism, because they said we have a lot of SAP is a computer company, so we have a lot of coding, mathematics, and certain type of autism is very good in all this pattern analyzing. So they said, okay, these are people normally difficult to put in the workforce, but for our jobs, they are perfect. So we will try it, and they are very successful with it. So what does it mean for the future? We, especially in HR, we need more forecasting trends to see what will happen in the future, what skills will be required, how do we get the workforce we need, what do we have to do in the market. And we have to adapt, right? We are not able to do the same like we did last 10 years or so. So we have to look at the different trends. How does the work change? I think 10 years ago, nobody would have thought that we can use artificial intelligence for so many things in our normal work environment. That means that we would have jobs that we do not need anymore, because or the AI can do it, but we need people who are able to deal with the AI. So we upskill different skills. So it's not that we can do the same as ever, but we have to, and also in Europe, should collaborate to see cross-border initiatives. How can we learn from each other, best practices, what works in one country, can we adapt it in our country as well? So we have a lot that we can. So that means the demographic we cannot change. We cannot force all the people, hey, we have a lot of students, so get babies, get babies, get babies. Perhaps in the long term, that would work. But before the babies that are born today are working, it takes 20 years. So it's more a long term. And we know it doesn't work because it's just ideas perhaps are different. And so we have to look at it. How do we deal with the talent gap? Training and development, the knowledge transfer, because we have a changing workforce. How to deal with the age diversity, with the young people working and the old ones. And of course, we want to have them as long in our company. Aging is also important. And therefore, we all need to work together to learn from each other and get good. Thank you very much for your attention.
Thank you, Professor Silke Michalk. So it's time for a question from the audience. Oh, there's a question.
Professor Michalk, very interesting presentation. My area of research are pension systems, pension economics, and it is interconnected with labor market. And the problem of aging society is crucial for pension systems. Few days ago, there was interesting research results published in Poland. We have 7.5 million people in retirement, and most of them do not want to work longer. After reaching pensionable age, they want to stop. But nevertheless, 800,000 people still continue working after retirement. So it is changing. And I think you have mentioned in your presentation that there is need for more elasticity, especially for older workers, to attract them to work longer, retention of longer workers, and maybe part-time job. I think in Poland it is a huge obstacle that many entrepreneurs do not want to hire elderly people for part job. They want to hire new, young people, which is not always the best solution. Maybe one more remark. There was, Hayek, representative of liberal concept of in economics, and he said that free market economy is much better than planned economy because people who work in company have unique knowledge and unique abilities. And elderly people have this knowledge from their long time of work. So you are right that the problem of succession and how to transfer knowledge between young and older people working together is also a huge, huge issue. So thank you very much for presentation.
Thank you.
Maybe one more question, and it was a very interesting presentation, especially that one of the slides was amazing, yes, when you presented at the very beginning, yes, you presented the numbers of the Europe and how it looks like, and in Poland we've got very negative situation. I would like also maybe tell two sentences about what Professor Marek Szczepański said, because you presented some very interesting idea about big players, yes, like BMW, yes, and Bosch, Saab, and so on. It's very interesting. In Poland, we've got the system like 500 plus zloty. Actually, right now it's 800 plus zloty. It's for the family, to the one and second and next child. But actually, the target of this program was to make better population. Yes, but actually, I think that we haven't managed to do it. And I've got the question: do you think that maybe some tax benefits to the organization could be the solution for the organization, like I don't know, 2 or 3%, they are going to have a better tax program. Of course, it is the idea, yeah.
Okay, I'm not quite sure if tax programs for companies will really help do something. Okay, I'm not a real fan of subsidies by the government, because here it's more about what can the company do by themselves, what do they have to think about it, how do I attract employees, and that's not, I have to pay less taxes or something, and they will not use, you cannot use the money to attract the employees perhaps, because then you have to spend more money on them. So I think then if you want to have the older ones longer in the job, it's more that the tax reduction will go to the employees so that they do not have to pay taxes, so that they have, for them it will become attractive to work longer because they get the whole money and not to have pay 50% of them as taxes or something like that. So that makes more sense for me, but for the company, it's not that they will get less, that they have to pay less taxes, and when they have money to spend it more on the employees, that will not work.
Thank you once again, Professor Michalk. Professor Michalk was talking about well-being and work-life balance, so it is now time for the long-awaited lunch break. So, ladies and gentlemen, the lunch is going to be served in the same room as previously the coffee break, and you are kindly asked to return to the lecture hall at 3:15. Thank you.
Test, test, raz, dwa, raz, dwa.
Ladies and gentlemen, we are now approaching the final part of today's presentations. And I would like to invite the Dean of the Faculty of Computing and Telecommunications, Professor Mikołaj Morzy, and his guest from the Politechniki Institute of Visual, Professor Rui Pedro Duarte.
Ladies and gentlemen, it's my great pleasure to welcome you today to today's lecture. As we gather here at the Science Day at Poznań University of Technology, we're reminded that the true essence of engineering extends far beyond just optimizing the algorithms, all the elegancy of the code. One of the greatest properties of engineering is that it has a profound ability to address real-world problems and really make people's lives better. Engineering is not only about solving problems, it is about creating the world in which those problems simply no longer exist. And today we have the honor of hosting a guest who embodies this vision of engineering through his diverse research. Please join me to welcome Professor Rui Pedro Duarte from the Polytechnic Institute of Viseu. Professor Duarte brings interdisciplinary expertise, holding PhD in informatics engineering, master's in computational methods in science and engineering, and a background in applied mathematics. And his research portfolio is just a testament to the versatility of modern computing because it stretches through machine learning, cloud simulation, atmospheric data, but also human-centered computing and emotional design. In today's session, he will share his insights on interesting application of machine learning models for detecting the progression of chronic diseases using the smartwatch data. Professor Duarte, we are delighted to have you with us here at Poznań University of Technology, and the floor is yours.
Okay, hello, everyone. I hope you had a good lunch. This moment, maybe your heartbeat would be between 60 to 100 beats per minute after lunch. It's normal value. First of all, thank you for the opportunity to be here presenting the work that we are doing in our research group at this moment. When they asked me to present something from our field, it was a bit difficult to choose because, in fact, as you said, we have a lot of work and we focus a lot on societal needs, on people's needs, and also on people with disabilities, people with diseases. And this is the way we try to put computer science next to society instead of being only related to pure computing or stuff related. In this presentation, we will try to cover one of the aspects that we deal with in our daily routines. That is, most of us, we have already smartwatches from different brands, of course, and we measure, and we are getting used to measure and use that information to gather some insights from our perspective as users and consumers of that information. The problem is that most of that information, it must have happened to all of you. We are on vacations, lying on the beach, and my smartwatch tells me, "You're stressed." I say, "No, I'm not stressed." It has to do with discrete metrics that are used instead of continuous metrics. One of the things that when we work with smartwatches, we have to consider that they have a lot of constraints in their use. One of them is the positioning of a smartwatch. We should always place a smartwatch, not in the bottom of our arm, but in beforehand, for the metrics to be well calculated and the results are adequate. So in this work, focusing on this work just a little bit before the use of smartwatches, we tried to use machine learning, first of all, to explore stuff related to a disease or two diseases, which are cardiovascular diseases and type 2 diabetes. One of the things that we found out, is that to study these two types of diseases, we need a lot of metrics, not only the VO2 max, which I will explain later, but we need a lot of other metrics that are important for us to combine together and to provide, at this stage, not clinical information, but user information about how they feel and how they are, in fact, in their health. This study is also a partnership that we have with Garmin, which provided us the equipment and provided us also access to their APIs to gather data and to store them locally. So the outline of this presentation, we have seven domains. The first of all is to give you, I believe that not everyone from here is from the computer science field or e-health related fields, so how important it is and what we can do with VO2 max indicator. Moreover, we will also explore, and what is the impact of low VO2 max in our health at these two types of problems. And then we will talk a little bit about the hardware that we use, which is the Garmin Venus 2 Plus. Why this hardware? It's an hardware that fits in some pockets, not all pockets, of course, but it has to do with a balance between cost and benefit related to how accurate are the sensors and the price of the equipment, because as I said in the beginning, we target this for us as users, not only for clinical aspects. If we want kind of like 99% accuracy, we would go to Empatica, for example, which is very, very expensive, but it's not related to us in our daily routines. Then we'll talk a little bit about the problem that we dealt with, the objectives that we have in this presentation, and what we expect to obtain. How do we have built up our architecture? We have a database that acquires information from the smartwatch and other aspects. Then we enter the machine learning models, selection of features, model validation, and training, validation, and then the tests. Finally, the conclusions that we took. As a general view, what we have here is we acquire data from smartwatches. Okay? This data is acquired by individuals, or one individual, and then since we do not have clinical data yet, what we do is we extrapolate this data to check whether we can have good measurements for Garmin to consider the validation of this work as something that could be implemented. And then, of course, in the next stage, we will go and talk to patients and clinical staff. So what is VO2 max? Basically, it's obtained from tests. Well, basically it's the amount of oxygen that we can obtain from intense exercise. The impact of this is that the intense exercise is not for sports people. Of course, when I practice exercise, my intense exercise may be completely different from the intense exercise of someone else. So, but basically, this is done in laboratory with masks and where the oxygen is extracted from the breathing of the person, and then we get the value of VO2 max. The Fick equation that we see there shows the components, the cardiac output, which is multiplied by the difference in the arterial venous oxygen content. But why is this important? Clinically, oops. I forgot. Get here. I'm really sorry. I was here, and now I'm talking about part there. I don't see it fit points. No. So basically, what I said is what VO2 max is and what it stands for, and the equation, the Fick equation, and basically the fitness level of VO2 max can be measured. There's a strong predictor of longevity that we have cardiovascular risk and metabolic health. For example, with a person that has a VO2 max over 55, is considered to be with superior fitness. A person who is below 20 is considered in critical fitness. So we create here a threshold that we will present later, about 47 as value, that we consider with risk, okay? The person with risk. Next, how does VO2 max drive chronic diseases? I will look here because otherwise it will be difficult. VO2 max implies on chronic diseases in several ways, but first let us consider that the global burden is very significant. About 80 million cardiovascular deaths occur in the world per year. Moreover, we have 537 million adults who live with type 2 diabetes. The critical threshold we consider as risk is 41.7. Below that, the value increases up to 3 times. In the causal diagram, or the causal pathway, we can see 2 paths. The one that goes for a cardiovascular disease and what impacts on it, and the other one that goes to type 2 diabetes. On the cardiovascular disease level, low VO2 leads to reduced cardiac output, increase in blood pressure, an increase in inflammation, and also provokes arterial stiffness. This leads to cardiovascular disease. On the other one, on the metabolic side, it causes insulin resistance and also impaired glucose regulation. This provides type 2 diabetes. Of course, that both of them share the same root causes, which are sedentary, obesity, diet, and aging. Okay, before moving to data, we should consider the value of using smartwatch, the accuracy of a smartwatch. As I've said earlier, we use the Garmin Venus 2 Plus smartwatch because it provides good precision, results with correct usage of the device, and it contains 5 components: an optical PPG, heart rate sensor, a HUMO accelerometer, GPS altimeter, and the first bit proprietary AI algorithm, which allows them to calculate VO2 max, and this is from another company. The accuracy is clinically adequate. The mean absolute error of plus or less 3.5 versus the gold standard of Douglas Bar methodological analyzer appears a correlation of 0.87 and 95% of readings within one VO2 max category of the CPET result. The CPET result is one that we do clinically in a laboratory. Also, first bit analytics have been validated over 60 peer-reviewed studies. Our research framework, it's here also. Our problem is the chronic diseases like cardiovascular disease and type 2 diabetes are often silent. We don't see them appearing. They're progressing between medical checkups. So instead of having the discrete time lapse, we can have from our side, from the user side, information regarding if we are getting in a medium, low, medium, or high risk of developing or being with some sort of cardiovascular disease or manifestation of cardiovascular disease or type 2 diabetes. The clinical stress tests are expensive, of course, and inaccessible to many patients. In this case, the digital screening is a low-cost alternative. It's not a clinical alternative, it's a user alternative to know if something is happening. So the main objective is to develop a machine learning system to classify risk levels, low, medium, or high, based on criteria that we will present later, in an early stage using non-invasive wearable data. The results that we expect to occur include the validation of VO2 max as an indicator of cardiovascular disease and type 2 diabetics, and the addition of other indicators as a relevant feature, which allows us to create a valid structure for us to define
if we are in the presence of a risk of having type 2 diabetes. Now, regarding the architecture of the system, what we have here is 5 stages. First of all, we acquire the data, and of course, data acquisition is done by the Garmin smartwatch, and also the HydroSpark 3, which is a smart bottle that allows us to incorporate ingestion of water instead of using the manual input that we have on many smartwatches for water intake. We wanted to take the user out of that annoying interaction. Okay, by acquisition of data, then we pull this data through the Garmin Connect API, and we have selected 18 metrics that are related to this type of diseases. Then they're stored in a PostgreSQL with JSON-B format. For data preprocessing, we use a robust scalar normalization and recursive feature elimination. We will see for those who contribute more to the results. And then we apply 2 machine learning models, the support vector machine and linear regression, just to test differences between one and the other. We use these 2 because in the literature, they are the ones that are most used in these scenarios. Of course, there are others, can be further increase the study with others. We want, as an output, the decision whether we have low risk, medium risk, or high risk of developing cardiovascular disease. Regarding the hardware and software stack, so as I said, we use Garmin Venus 2. We collect physiological signals as basically a lot of them: VO2 max, heart rate, SpO2, respiration, sleep, steps, and body mass index, among others. Then the Garmin Connect app syncs the data with Bluetooth with the Garmin Connect API, which allows the extraction of this information to store in our database. Regarding the metrics, we have selected, as I said, 18 metrics, which include VO2 max, fitness age, SpO2, and multiple sleep metrics, because sleep has a deep impact. The quality of sleep also has a deep impact in developing cardiovascular diseases. And again, we use the HydroSpark 3 smart bottle to add data to the database, and then which is a PostgreSQL database relational using SQL Alchemy. Next, regarding the pipeline, how we store stuff here, we have 6 tables, which are the source tables where we store the data: activity, finite, sleep, oxygenation, hydration, and other user metrics. And then we put it all in a single central table, which is related to the person, which is person record machine learning, or data to be used in the machine learning process. So regarding with this, we have the 18 metrics that we use in the okay, and then we use it for the data set to be explored, and the information is extracted from the smartwatch. The table with the association criteria between different metrics, instead of having a single threshold, we designed a multiple metric weighted scoring system, which was validated using the literature also and healthcare professionals. For each metric, for the combination of each metric, we have associated a weight. For example, VO2 max is combined with body mass, the first one, body mass index. The first one up there, with body mass index, and then the validation criteria is the highest rate that when body mass falls between 41.7 and body mass index is outside the health range, this contributes 0.3 to the total risk. Of course, the sum of all weights has to be 1. Next. Regarding the data sets that we have used, we have created 4 data sets related to user data, and we have compared them to purely generated data sets. We wanted to explore the difference that we have in purely synthetic data sets and data sets that were smartwatch-based information that was extracted. So we'll have 4 data sets. We will compare between 2 for cardiovascular diseases and 2 for type 2 diabetes. One of the data sets, as I said, is based on the smartwatch data, which we have extrapolated. Thank God it was a healthy person. We had to extrapolate the information to acquire more data for us to assess the risks that were made or were able to be in the person's values. Before training the machine learning models, we used recursive feature elimination to identify the most representative features and reduce, of course, the dimensionality. The dataset was split 80-20 for training and testing. Recursive feature elimination iteratively removes the last features relevant using random forest towards the estimator, and the random forest can capture both linear and nonlinear relations and is robust to correlated features. The hyperparameters tuning used to randomize search CV for efficiency, which explores a wide parameter space without the cost of exhaustive grid space. Cross-validation used time series split, which is critical for temporal data. It preserves chronological order and presents data leaking from future to past. First, the results, which are related to cardiovascular diseases and are not related to smartwatch data, which means that they are purely synthesized information, which we call the independent data set. The RFE, recursive feature elimination, shows that results are highly consistent. Across 10 of the 12 configurations, the exact same 7 features were selected. They are presented below. These features were selected. For those features, for example, VO2 max, body mass index, average SpO2, sleep time, and sleeping resting heart rate appeared in every single configuration, 12 of the 12 configurations, which confirms their strong discriminating power for the measurements that we have. Steps and average sleep SpO2 appear in 10 of 12. The best setting was 25 with 5 CV splits, which are also the fastest, which is important for matters of scalability. When we look at the defined or the smartwatch data, now based on the data that was acquired with the smartwatch, all 7 core features appear also in every configuration. This is higher consistency than in the independent data set. The difference is that the resting heart rate replaces steps as the 7th stable feature. The steps only appear in 4 of the 12 configurations here. This shift makes physiological sense because real smart data watcher provides high-quality continuous heart rate monitoring, which making resting heart rate more informative than step count, which is easier to estimate artificially. And next, we go to the type 2 diabetes feature selection with the independent data set, which is not related to the smartwatch data. Here we get 6 core features, which are body mass index, VO2 max, sleep resting heart rate, sleep time, daytime HRV, and average SpO2. Daytime HTRV appears in all of the 12 configurations, which is a type 2 diabetes specific feature that does not appear in the cardiovascular disease optimal set. HRV captures autonomic dysfunction linked to insulin resistance, which is one of the characteristics of type 2 diabetes. The optimal configurations require more iterations and splits, 75 and 10 splits, than cardiovascular diseases. suggesting that type 2 diabetes features relationships are more complex to establish than for cardiovascular diseases. Next one shows the exact same tests for smartwatch data, for information based on smartwatch data. The optimal configuration gets to 100 iterations with 10 CV splits. The most computationally intensive of all configurations. The 5 core features, body max index, VO2 max, sleep resting heart rate, sleep time, and heart rate availability during the day, are stable across the 12 configurations. Resting heart rate re-enters as it did for the smartwatch cardiovascular disease dataset. Average SpO2 appears in 8 of the 12 configurations, and total calories in 7 of the configurations. The best 7 feature subset is stable across 75% of the configuration. So with this, we identify the features that are more adequate for each of the tests in the feature selection before we start entering in the machine learning models. As I've referred, we used 2 classification algorithms, support vector classification and logistic regression. SVC finds optimal hyperparameters that maximize the margin between risk classes. They handle nonlinear relationships through the RBF kernel and multi-class problems natively. It provided the best performing model across all 4 datasets. They took longer to get results, but they provided best results. Logistic regression is a simpler model that we use as a comparison baseline. It's much faster to train and provides class probabilities, but only models the linear relationships that are established between the classes. And hyperparameter optimization uses grid search CV, which is an exhaustive search across all parameter combinations, select configuration with the best average validation performance. In the training phase, this is a lot of technical information, but what I will show is that the one that provides best results. Was it me? Okay. In summary, when you're looking at information for cardiovascular disease not related to smartwatch data, with 5 splits, SVM is the best method with a precision of F1 of 0.83 approximately, and the gap that exists versus the logistic regression is consistent, approximately 4 percentage points across every metric. The bottleneck is that SVM takes about 14.2 minutes to train, and logistic regression takes 1.2 minutes. So it's much slower, but the accuracy gains if you look at the medical screening context, and that may justify the computational cost. When we look at the smartwatch data, the results are pretty much similar. Again, SVM takes about 21 minutes, and logistic regression takes 1.2 minutes. Once again, the accuracy benefits justify for clinical screening tool. When we go to the test phase, what we get is that when comparing the data set, our headline finds the CVD smartwatch test, this is for CVD, are the headline finding of this study, 90.13% balanced F1, 91.5 precision, 91.2 recall, and the accuracy, balanced accuracy, 90.8. The smartwatch dataset outperforms the independent dataset by approximately 6 percentage points on every metric that we are studying here. So real wearable data captures physiological patterns that better reflect real-world risk distributions, even though it has more noise on the data. And then if we go to the analysis of the confusion matrices, this is just the analysis of them. These errors, clinically, what do they mean? Of course, the biggest risk is to classify high as low or low as high. This does not occur in any of the data sets. All the misclassifications are in adjacent classes, which is acceptable within the screening context. The smartwatch data reduces low to minimum errors by 56% and high to medium errors by 55%. The high risk class achieves 94.2% accuracy, which is the most important. When we have a high risk, this is the most important class where we want to get it right. We want to get this one wrong. So on the other hand, the medium risk class is one of the most difficult for both data sets because they can be either in one of two positions, on the low risk or on the high risk. So these errors need to be reevaluated. Concluding in this, regarding to the CVD model, what we have is the SVM is the best classifier for the independent and the smartwatch data set, which allows us to justify that, okay, it was expected, but one of the things that we consider also is that, in fact, we have good results. We are not looking at pure smartwatch data. Okay? We have smartwatch data that we have extrapolated, that we have increased to get information on the diverse levels of someone that can be in low, medium, or high risk. And then we compared it to synthetic data, and the results, in fact, allow us to conclude that sensors from smartwatches can provide, at the level of cardiovascular disease, can provide us good information relating the cardiovascular disease. If we go to training of the type 2 diabetes and the analysis, what we show is, once again, the SVM scores better than the linear regression, logistic regression, and at the level of the data, that's not related to the smartwatch, but also when we compare it to the data that's related to the smartwatch. In this case, for example, the SVM-LER gap is the largest across all data sets, 8.1 to 8.5 percentage points on real world, which confirms that on real world scenarios, SVMs is superior for metabolic disease classification. At the test level for type 2 diabetes, the same happens. Smartwatch provides best results. The best results for the 3-class risk certification problem using non-invasive wearable data. The 2-point percentage average of a smartwatch is consistent over all metrics, which confirms that the real sensor data improves type 2 diabetes classification as well. The confusion matrix also shows that smartwatch data eliminates the most dangerous error, low risk classified as high risk. The low risk accuracy goes from 83.2 to 92% with the smartwatch data. The increase in high to medium errors with smartwatch data borderline cases, which heart rate variability and skin temperatures are ambiguous. This may impact on the results, which is something that we are already looking into. And medium risk, once again, maintains it as the hardest class to classify. Once again, the SVM model is the best classifier, either for the smartwatch-related data to the non-smartwatch related data. Conclusions. The random forest with RFE was effective at identifying informative features across all datasets. Stable results across multiple configurations give us confidence in the features that were selected. SVM consistently outperformed logistic regression by 4 or 8 percentage points, depending on the dataset. Datasets based on smartwatch can be better generalized than purely synthetic data, which validates our design approach. VO2 max and body mass index, SpO2, sleep duration, daily steps, and resting heart rate are the most critical features for both diseases. The limitations of this work are related naturally to sensors as all. Even though we have used sensors which are in the more or less 3.5% of error, we need to consider that this is only, we do not want it to be something that's clinically validated as a clinical test, because that's not possible, but look it as an option, or it could be included for the usage of us as humans to understand how we can improve and know if we are taking any risk when carrying out either sports or in our daily life and in our work. Once again, the sensor has some gaps. We cannot measure directly glucose or blood pressure, which would be important. And risk class certification is not yet clinically validated and correlated with actual and real patients. What we want to do next? Increase, get new smartwatches. This is something that we have to say because it's important to say, but increasing the quality of the sensors of the smartwatches will cost us more money, and is something that we need to keep this balance of something that can be bought for everyone. Expand the dataset, gather more information on the dataset, and use other methods of machine learning also to compare results, even though these are the tools from the literature that are more used. And of course, include that we are trying to do now, healthcare professionals and patients to validate some of the results that we have obtained and use the model as it is to to validate it in real life context. Thank you.
Professor Duarte, thank you very much indeed for a very interesting presentation. And now it is time for us to ask any questions that you would like to put to our here today. Yes, okay.
So I reckon that are important for our point of view of our health. I know how to improve BMI. I know how to improve the length of sleep or number of steps I take every day. What would be your suggestion? Is there a simple, direct way to increase the volume of oxygen that we intake, or this is just the result of a long training?
It's an interesting question because well, it has to do, I think, with most of us. When I look at the audience in the top there, they run and they don't get tired. When I look at the audience like me, we run and we get tired. But if we look at someone like me, a different data set, which is someone that practices a lot of sports, it can also have problems with cardiovascular disease. So it doesn't have really to do with one value that we can determine, but the combination of a lot of factors. And that's why this one is called the silent disease, because we don't know. We know that there are 4 pillars that affect it, but we don't know what we are doing wrong in our daily life that can affect the results that we get, or we can potentially have heart disease. Another thing, it's hard because it's hard to measure. We don't see it coming because this doesn't measure the amount of fat that we have in our veins, of arteries, of course. Thank you.
Thank you once again, Professor Duarte.
Now, let me invite the Dean of the Faculty of Mechanical Engineering, Professor Bartosz Gapiński, and his guest from the Université Polytechnique de France, Professor Christophe Maréchal.
So, dear ladies and gentlemen, on behalf of the Faculty of Mechanical Engineering, the oldest faculty of our university, I'm delighted to welcome you. To celebrate today's Science Day, we are honored to welcome Professor Christophe Maréchal from University of Valenciennes in France. In his work, Professor Maréchal consistently combines theoretical approaches with experimental methods. This philosophy is reflected both in the scientific research and the various courses he teaches. His PhD research is focused on finite element modeling of robotics glassblowing. He then began research aimed in improving the understanding of impact phenomena at low ballistic velocities. This work originated from observations made by Criminal Investigation Police Department regarding the lack of reliable methods for identifying ballistic parameters of shooting trajectories during criminal investigations. These methods are based on experimental testing and numerical modeling. They enable the design of physical substances, of biomechanical testing, and support the development of new models of injury biomechanics. Following his appointment as a full professor 4 years ago, he shifted his research focus towards musculoskeletal modeling. The objective of this work is to assist clinicians in better understanding the causes of trauma affecting the femoromandibular joint and estimate its consequences for the body as a whole. Dear all, it's my great pleasure and honor to introduce Professor Christophe Maréchal and to invite you for his lecture.
Thank you, Professor, to introduce me for my presentation. So I'm Christophe Maréchal. I'm professor at the Université Polytechnique de France. And my presentation, we talk about musculoskeletal and finite element modeling in biomechanics with a focus on the temporomandibular joint models we are developed in our laboratory. To provide some background, my presentation. So, when I start my rock research in 2003, I work on the modeling of the head and thorax for a ballistic application. So, since 4 years ago, we decided to change my research activity, and at this time, I decided to work on the use of a musculoskeletal and finite element model to increase the understanding of injury in tissue. And this change of my activity corresponding of a reorganization of the laboratory LAMI. So the laboratory LAMI composed of 4 departments. We have automatic department, mechanics department, computer science department, and human and life science department. So we have in 2 department activity in biomechanics. So in mechanics, we have material characterization application for determine the behavior of tissue in biomechanics, and we have motion analysis of a human body in the human and life science. So we decided in 1 year ago to change the composition of the laboratory, and we group 2 teams. We work on biomechanics, and to create a new team, that biomod team, and I am now member of the biomod team, and I work on musculoskeletal and finite element models for injury in tissue. So my presentation follows this summary. So I start by a presentation of biomechanics and make a focus on the anatomy of the jaw and the TMD. After I present the musculoskeletal and finite element models we have developed for the jaw, and I finish by conclusion and research prospect. Biomechanics can be defined as the study of the force and movement of living organisms and their components. So biomechanics was in the interface of three scientific fields. So we have an interface on the mechanical, biology, and motor control. That's this why biomechanics is not simply because you are need of expertise of all people we have in mechanical, biology, and motor control. And you need to have a possibility to discuss with all the people. So we can distinguish the biomechanics at the macroscopic scale. So when you work on a macroscopic scale, you work on the full body, on body segment, and you can work in other parts on a microscopic scale. And this part, we work on cells and protein. So we find biomechanical application in sport, clinical, biomechanical engineering. And say for my work, the overall objective was understanding the dysfunction and engineering in tissue. If you look biomechanics in the perspective of the motion analysis, the aim will be to study the movement of the human body limbs. So with this study, you can identify kinematics parameters of motion, then acceleration, velocity, displacement, force moment. And to determine force in muscle, you can use rigid body models. So in this case of analysis, we identify injury or damage by criteria. Then the head injury criteria and brain injury criteria with very use on the crash test in automotive. But we don't use finite element models to research the behavior of the tissue. If you look at biomechanics for different perspectives than for microscopic scale, so we decide to study the strain analysis and to find function between strain analysis and strain and stress level. So you can make this model for rheological and tribological study. And you need to develop a lot of experimental characterization protocol to determine the behavior of tissue than the elastic behavior, plastic behavior, viscoelastic behavior, and hyperelastic behavior. So when you want to model this type of study, you need to use deformal model based on finite element formulation. So we present in the right of the side the UBIX model, that's a thorax model in finite element models, and the Wayne State University head injury models, that's a finite element model for to the head. So now I decided to change my research, as I said previously. And this new approach we decided to develop was a multi-scale biomechanics modeling. So we want to use macroscopic motion analysis and parameters we can find with this macroscopic analysis to integrate these parameters in finite element models to determine and understanding the injury in tissue. So we decide to compose this method in two steps. First step is use the analysis motion to determine the muscular forces. And in this case, you used musculoskeletal modeling to do this. And the second step was to determine the injury in the tissue. But in this case, you use the finite element modeling, and you can find link between the step 1 and step 2 by integrate force activation muscle in the finite MO model. So for all model we have developed, it's very important for us to want to be capable to customize the model, because it's very important to identify the inter-individual parameters that play a key role in the tissue image. So my presentation make a focus on the modeling of the temporomandibular joint, but actually we have a new project on the neuromusculoskeletal modeling of the risk of ligament and tendon injury in the knee in the PhD thesis by Florian Kuer. So to provide some background of this Mandipos project. So this Mandipos project is the first project we obtained and find financement to the region of Hauts-de-France. And this background of this project is, the aim is to identify a link between postural disorder and temporal mandibular disorder. So the context of this research was three parts to do the research work. So first we make a patient follow-up to have a lot of inter-individual information about a patient. Yes. Slide. So, and after we developed a motion analysis protocol to determine kinematic parameters for the motion of the head and motion of the temporomandibular joint, and we developed a characterization test and models to determine the injury or not behavior of the disc on the temporomandibular joint. So I start by a small presentation of the TMJ anatomy. So the temporomandibular joint is links the mandibular condyle to the temporal bones. So the jaw is composed of maxillary bone and mandibular bone. So you can see. You can see here there are the mandibular bones and the maxillary bone. And the temporomandibular jaw joint is composed of condyle. Condyle is at the extremity of the mandibular, and the temporal bone, and you have a disc we are placed between the condyle and the temporal bone. So in this is a video recording, so I don't know if it's possible to have motion. Ah, yes. So in this video recording, you can see the motion of the condyle. So this place, you have the condyle we motion with the temporal bone, and between the two bones, we have the disc. We are moved forward, up and bottom, and we have a lot of deformation of the disc during when you speak, when you masturbate. So the jaw was composed of a lot of muscle. So we can find two types of muscle on the jaw. We have levanting muscle. We participate to the closing of the mouth, and depressor muscle. We participate to the opening of the mouth. So if I speak about disorder in temporomandibulary, the etiology is very complex for the disorder. So it's complex, multifactorial, and stress plays a prominent role in the pain that link for this disorder. The consequences of this disorder was pain around the jaw. I think if I ask to you if you have sometime pain on the face, I think you have a lot of pain on this part because the stress make contraction of muscle, and the contraction of motion we have augment the deformation of the disc in the jaw. And after you have pain, you can hear clicking and grinding noise in the jaw, and at the end, in the big disorder, you have a limitation and locking of the jaw. So the temporal TMD was the main cause of the orofacial pain, and the second major cause of pain of musculoskeletal system. So our model, we are used to increase understanding of the mechanical stress in tissue, and more especially on the disc. So we decide to design a motion analysis protocol. This motion analysis protocol was to determine the kinematic parameters for mandibular kinematics and cervical kinematics. So we want on this Mandipos project to find a relationship between mandibular posture and cervical spine posture. So you have an incorrect head and neck posture. In this case, you have different facile morphological development for young people. You can find increase of muscle torsion on the neck, and in this case, you have pain on the neck. And you can find cranomandibular disorder, including malocclusion. We have the teeth is not in the good position, and you can reduce the mandibularity of mobility, and we increase the TMD. So this protocol, motion analysis protocol, has obtained agreement to the ethic commission. The motion analysis protocol was carried out with 16 markers. So we put 7 markers on the head, 6 markers on the thorax, and 3 markers on the mandible. But for the mandible, we use dentally supported system that we glue on the teeth of a subject. That's why we need to have approval of the IT committee to do this protocol. And the video recording with the optoelectronic device, then calysis. So the protocol was applied on the 37 healthy subjects. We just carry out on healthy subjects because we don't have the authorization of the committee to use person and people we have trauma or deformity or we have disorder on the jaw. And when you practice the motion analysis, we ask to the subject to make a static position during 10 seconds. After we practice some motion of the head, the motion of the head was made with a comfortable velocity, but we can make, after we asked that we can make this with a high velocity. So we ask to the subject to make open and closing of the jaw, and we end the motion analysis by a static position. So you can see here the movement recording for one subject. So this recording in left, you can see the video recording. And in white, we can see the marker tracking data obtained using the visual 3D image processing software. So with this analysis, we can measure several acceleration and angle on the head and on the mandibular. So I present here in the left the result for the measurement between the horizontal line that we pass on the spinous process C7 and the line connecting C7 to the tragus. Tragus is a point on the hair, and we can measure, for example, the type of angle during the motion. And in white, you can see the graph of open and closed displacement for the mandibular. Oh, nice. So in this table, we can find the first result we obtained for head flexion, head extension, and jaw opening and close. So we find a little difference of the amplitude between the velocity. So actually, we don't find significant correlation between cervical movement parameters and jaw movement parameters. So data analysis is currently underway. I think we need to make this motion analysis on people we have disorder on TMG to find difference between this motion. So now I present to you the model was developed in our Dismondi Post project. So the experimental data we obtained on the motion analysis, we use this in the OpenSim model to determine the muscle force activation. And muscle force activation was used to integrate in the finite element models to determine stress and strain on the tissue. So modelization starts by creating a geometric model using CT scan of patient. So we make a 3D scan, a 3D analysis, and you can generate a STL file. That is STL file was used for design the OpenSim model and the finite element models. So to model the muscle, so I talked about the muscle previously. You have elevated muscle and depressor muscle. So two major models exist in the literature to model the muscle: the Hill macroscopic model and the Oakley macroscopic models. So the Oakley model is constructed by taking account the molecular and fiber structure to predict the tension in the muscle. But we used OpenSim, and OpenSim used the Hill model. So this model is composed of 3 parts. We have a contractile element. The contractile element CA was a part of the model. We had calculated the active parts of the muscle. We have a spring to represent the passive part of the muscle. And in serial, you have an elastic spring that represents the tendon participation on the muscle activation. So to determine the force activation, you use this curve. This curve was you can find the length of the motion in function of the normalized force and the normalized velocity. So this model was hyperelastic models. So it's important to take into account the velocity in the model to have a good calculation of the rigidity. So this model, so we developed in OpenSim model of the jaw. So I present here the first model we have developed. So to make this model, we need to first create the geometry of the bones. After, you can add connection between the bone. So in red you can see the muscle we have put on the model. You add markers and you make a scaling of the model to adapt the model of the geometry of your base that you make the study. So with this type of model, you can make inverse kinetic calculation to determine arm translation and static optimization to determine muscle activation. So in left, you can see the first model in OpenSim we have made to the jaw segment of the head of human. So to this model, you determine kinematic parameters using the opening dataset we have obtained on the motion analysis. And we can practice static optimization to determine the muscle activation. And this optimization we base on minimizing an objective function between the experimental data we obtain on the motion analysis and the result of the calculation. So I present here the first result to obtain for the activation of elevating muscle and depressor muscle. So in left you have the elevating muscle. You find you can see on the graph the time of movement for the subject, and the activation force we are determined by OpenSim. And in right we find the depressor muscle, and depressor muscle was more for closing, opening of the jaw. And we can find the time of opening of the subject and the activation of the depressor muscle corresponding on this motion. So in order to, we have developed the OpenSim model. OpenSim model, it is a musculoskeletal model. We, in parallel, decide to develop Abacus finite element models. So this finite element model is based on the STL file I present to you previously. And this STL file we use to generate the mesh of the finite element models. So when you make a finite element models, you need a property of materials. And so for the property of materials, for the bone, we use the literature and property of we find in literature. So for the disc on the jaw, we decide to develop two experimental tests. One for rheological characterization of the tissue and one for tribological. So the test we have developed on the tissue characterization and for the rheological test, we use the DMA device. So this DMA device can determine the dynamics parameters on the tissue. And to do this analysis, we extract some sample on a pig disc. We don't use a human disc because it's complicated to use a human disc, but in the literature indicates that their behavior very similar than human disc and porcine disc. So with this sample of 4 millimeters diameters, we practice a dynamic test with DMA. The dynamic test was for frequencies between 0.1 to 10 Hertz. And with this, we can determine the storage modulus of the tissue. And the storage modulus we find vary between 0.06 ampere to 0.1 ampere to 10 Hertz. So we developed another test. The other test is for tribological characterization of the disc-condyle contact. And we saw on the slide on the anatomy of TMGs that we have a contact between the disc and the condyle. So we decide to design a new test to determine the coefficient of friction between the disc and the condyle. And for practice this test, we fix the condyle on the upper plate and the disc on the lower plate for the Ebola-Brucker trigonometers. So we practice the displacement between condyle and the disc, and we measure the tangential force, but we impose the normal force on the disc and the condyle. So with this test, we can determine the main friction coefficient between the condyle and the disc. This coefficient friction was 0.2 268, and this we can use this friction coefficient in finite element models. So we design, this is the first finite element models we are designed. This is a simplified finite element model because we developed this model in the same time that we have developed the model in OpenSim. And when we develop the finite element models, we don't have a result in active force, and we don't have a result of experimental test. So to test the finite element models, we used activation force curve found on the literature. So we use the Comiso and Holt synchronization force curve, and we impose boundary conditions for the displacement of the condyle to simulate the presence of the disk. So this is the preliminary result we obtained with these finite element models. So we don't observe the same type of condylar displacement that's seen in dental axiography. But in terms of displacement, the magnitude were very similar as those reported by Comiso et al. So I think we have a lot of work on these models, but this is in the good way for continue develop it. And in conclusion for the research project, so the implement motion analysis protocol enables us to characterize head function and jaw movement. So we have developed two tests, rheological test and tribological test, to determine the behavior of tissue. We developed two models, one model for OpenSim for musculoskeletal models. So we can make the estimation of muscle force activation. And for the moment, a simplified finite element model on Abacus way, but we want to increase the development of this model. And in perspective, we try to make replication of the motion analysis on patients suffering from TMD, but we need to have agreement of ethics committee. We want to make integration of clinical data to validate and personalize our models. We want to integrate disk into the finite element model to have a best calculation of the displacement. We developed a tool for measuring mandibular bite force. This is a new test we want to practice on the subject. We want to realize rheological and tribological testing on the SHPM sample, but that's the same for patients suffering from TMD. We need to have the agreement of ethics committee. And now, I hope it's possible, we work with Poznań University of Technology to work on the development of physical and numerical twin of the jaw. Perhaps I hope it's possible. So I want to thank all members of my team for this work, the work on this project. And so thank you for your attention, and if you have any question.
Thank you, Professor Marshall. So are there any questions? Audience? Oh, yes, there.
Hello, thank you very much for the presentation. I've got two questions, actually. Is there any reason you used OpenSim instead of anybody? The reason outside of the price, obviously. And the second question is, could you tell us a little bit more about the optimization process? We only saw, I believe, the minimization function. And could you tell us more about the algorithm itself?
So for OpenSim, we use OpenSim because we have a lot of setup on OpenSim, and it is very simply to use it to make the determination of and calculation of forces. But in OpenSim, we don't find geomodelization. So we need to develop this geomodelization. So it's very interesting for us because we need to practice in OpenSim and develop a new models and some new application and new behavior component of the segment. So for this and for the optimization, we just use the optimization system we have in OpenSim. We don't develop this, so we don't know clue. I think it's a generally optimization system we find on all software in finite element models or rigid body models. So we don't look if we don't have a lot of information about it. But we use this minimization. We use this optimization by compare the result of experimental data and numerical data, and this optimization to find the small error between these two. But I know that the results we have, that's the numerical result. That's not very realistic than we have in the live. So, thank you.
We now come to the last talk of the day. Let me invite the Dean of the Faculty of Materials Engineering and Technical Physics, Professor Mirosław Szybowicz, and his guest from Karlstad University, Professor Leonardo Martucci.
Good morning, ladies and gentlemen. I'm pleased to introduce the next and last speaker. At the beginning, a few words about Professor Leonardo Martucci is Professor of Computer Science at Karlstad University and Director on SIGS Cybersec and Swedish Industrial Graduate School in Cybersecurity. His research and teaching focus on security and privacy with particular emphasis on usable security, applied cryptography, security education, and the emerging use of AI in penetration testing. He has led and contributed to major international research education initiatives, including the European Horizon 2020, Maria Skłodowska-Curie Network, Privacy US, and has contributed an extensive research on privacy-enhancing technologies, human-centered security, and privacy and hands-on cybersecurity training. His work combines technical depth with a strong interest in how security can be made more effective, teachable, and usable in practice. His latest work centers on CyberRange Lite, a lightweight open-source CyberRange for hands-on security training and education, designed to provide scalable, individualized, and cost-effective training environments that support a realistic ethical hacking exercise and forms the basis of his Science Day talk at the UNIS General Assembly. He is the principal investigation on SPLAME, a newly granted four-year research project on secure, privacy-preserving, and efficient locally deployed IA system. Professor Martucci, the floor is yours. Thank you.
Good. So thank you very much. Thank you very much for the introduction. I have this unique privilege of being the last one or the last talk here at the Science Day. It also comes with a bit of challenge because I have to keep your attention for this last. I plan to finish at 5 o'clock. I don't want to push the envelope so much. So I have 22 minutes. And for you that are still here, and I'm going to take all the attention that you still have, I plan to reward you with something that's like a talk that'll be also practical, useful, and maybe with some space for cooperation in the future. Because what I'm going to present today is work in progress. It's not something that is finished, but it's something that's working on at this moment. And the title of my talk is The Practice of Security, Hands-on Security and Training at Scale, or how actually we'll build some systems for us to help our students, help our education, and how we're spreading it out so other universities, other institutions can also use. My name is Leonardo Martucci. I'm a professor of computer science at Calvin University. And my entire career, or how actually I've based it, is on building digital systems that people can trust. I myself am an electrical engineer that was bit by this bug of computer security for more than 25 years, and I turned myself into computer science that's been developing all my career, all my years of professional years or academic years in this field. One of my main courses of research is how to study it. I studied how to make cybersecurity useful, effective, and trainable. And that's how we're going to have the talk today. I'm going to start by saying why cybersecurity is hard in practice. A lot of us have heard about cybersecurity, but why is it so difficult? Why is it not a solved problem? Then I'm going to present to you a platform for cybersecurity training that we designed and developed in Calvin University called the CyberEdge Lite, and why this tool actually fulfills a gap that's needed, and then and it came basically for needs on academic needs on teaching, but also on the academic needs to create something that can all benefit. And also what I have learned from it and what comes next. And the red thread that we're going to follow in this talk, that security is not only about tools, programs, applications, and their configuration, but it's more about the people behind them, the people that actually use those tools, configure those tools, and apply them in our real life. But before we start talking about this, we have to think about why cybersecurity matters. So why do we spend so much time talking about cybersecurity? And the main idea is that use digital systems all the time. We trust digital systems. There was not maybe a single talk today that I had before that was about that didn't use any sort of digital systems. And you trust them. You trust them to do what you expect them to do. And those matters like education, is healthcare, is research, is social service, public services. Everything is based on digital systems and expectation that they work. But sometimes they don't. And a lot of times they fail because there's a cybersecurity incident or problem with them. And why these problems happen? Because the people behind those tools, behind securing those, don't actually do a good job. And why they don't do that? A lot of times it's mostly because people are not enough trained, or they don't have enough time to do things. People are stressed. And that's why security in principle is very fragile, because people are busy and the stakes are very high. And you want to take a decision under high uncertainty, when you have to take a decision when the problem is complex, most of the times you don't do it for 100% correct. And in security, it's really important to do things 100% correct, because maybe a single confusing setting can expose a critical service. I don't know if any of you, I don't know how many computer science are left in the room, but if you have ever tried to configure any cloud service, it's a nightmare. It doesn't matter if it's a Google one or Microsoft one or Amazon one. They all look different. They use different terms for the same things, and then it gets very complicated. Errors, a lot of time they arise for these unclear tools and cognitive load, because either the tool people don't understand them, or they don't understand exactly how they work, or they're tired, or they don't have the full understanding of what they do. And every small mistake that you make in this type of environment has a large consequences. What we like to say is that security by itself is a highly technical term. It's a computer science term, or it's a computer security topic. But it will like succeed or fail through the people that's behind it. Therefore, it's also a very human aspect. How we actually train the people to be behind that. How we actually make them better or more active to make like these type of systems work. And if it's about people, then the training of those people matter. How actually can keep systems secure? 100% depends on human decision. So, and when you provide better tools, people can act more confidentially and correctly. Therefore, better tools are needed. And for you to do this, you also need better training, because better training will help to build better judgment to practice. So in the end, you have like you need better training over better tools to actually make things secure. So there's a chain there. So the core idea that you have is that if security depends on people, then training is part of the solution. And if you take that as like something that we can all agree, then the training that we need like safe places where people can explore, fail, and try again. Why do you need safe places? So let's assume that you want to practice your security skills. If I go to my colleagues here from Poznan University and ask them, can I actually train my security skills on your like database, on your website? Most likely they'll say no, because people don't like to have like training on top of live systems. Because if you break things, then it's very difficult to put them together, back together. But you can provide like an environment that's isolated, that's virtualized, that's fail-safe, and then you can have people to train on those. Then you can provide something that people can fail, can break. And if they break, they can just restart the system and make it run again and again until they have something that they have learned and they can correctly work with. And then what brings us this training need and like our security needs when we want to talk to our students, talk to our computer security students, computer science students, what type we provide to them. And then what comes the Cyber Range Lite. And the Cyber Range Lite is a platform that initially we developed and designed for our security need, or like our education needs for cybersecurity courses. We built this for our, in principle, for our ethical hacking course. And we built it like first by ourselves, and also now we're collaborating with other Swedish universities to make something that is open and public for everyone else to use. And therefore, it's like one of my roles here is to be here to talk to you about this and to convince your institutions also to be part of that. But before you get convinced about it, I need to talk a bit more what it is. And the Cyber Range Lite is basically a flight simulator for cybersecurity. So if you haven't tried a flight simulator, it's just something that simulates an airplane. And when you simulate an airplane, you're very free to crash the airplane. But no one will give a real airplane to crash because it doesn't work. You probably can get hurt on the process. But when you provide a flight simulator for cybersecurity, it means that you have an individual training ground for hands-on cybersecurity. So get like it to experiment tools, experiment hacking tools, or actually doesn't need even to be about security. It could be like a networking or anything related. And you can break things. So also offers like something that's practical for the students to play with. It's repeatable, so we can rerun those exercises, something goes wrong. And we like zero reward risk because everything is not connected, say, from the internet if you don't want to. We can create for every student their own box, so everyone knows the students don't interfere with each other. So it's something that can provide individualized training. And have one place where people can explore, make mistakes, and start over. It means I broke things, I can restart. So at glance, is this isolated, unique environment that provides real services and realistic tasks. So everything that you have there is a service that exists. All the vulnerabilities that you have there are vulnerabilities that exist. We have vulnerabilities, usually try to take old ones because that's the and then the students have a chance to solve, and then we create those environments. It's used for teaching, so we use that for on your courses, but also for self-study. So I also have some for like your hacking club that you would like give to or like people join your hacking club to start practicing on exercises. It's very safe to experimenting. It's easy to reset and run, and really light to deploy. So that's one of our concerns when we start on this with this project. It was to create something that will be very lightweight, something that can run on this laptop that I have in front of me, like a 4-year-old laptop, or on PCs that you're going to throw away. So that was our objective. And that's what we did in that. So how the Cyber Range Light works, or CRL? The idea behind here is that an instructor, or like a teacher, prepares like the scenario, like think about like what should happen, how actually my network should look like, which devices I want to have there, which service I want to have into this, and think about a challenge logic. I want to have like this mistake on this configuration file, or I want to have like this software that was not updated here, or I want to have like one file running with privileged settings so one student can exploit. So I hide them into my devices and around my network, and I created this event or this exercise for the students to start working with. So the students then will launch their own isolated training environment called a ward. So every student gets their own word to play, their own network to play. And this platform, then behind the CRL plus some front end, will track the progress and interaction. So we can see what like the students do. We can track like their command lines. We can follow them around. And if they break something, they can reset themselves. So like, oh, I broke my system. They can reset. And resetting takes 1-2 minutes. In reality, we can do that in like less than a minute, in a matter of seconds. But because of some usability matters, we'll increase the time to 2 minutes. Anyway, under the hood, the Cyber Range Light, or CRL, is this lightweight orchestration layer that connects the events or the scenarios that the teachers create, the words of the students, and the challenge that those words have. So each student will get like this isolated environment that's running on top of like if you follow computer science, that'd be like a containerized environment running on top of Docker. But that's details, only if you're really interested. How it actually works in action. And for this, I have prepared a little demo. We have time for that, 9 minutes. And what I will do is like I'm going to launch an event. I'm going to access that environment. I hope to solve a challenge, and then we'll stop there. I'm going to reset. And that's like going to show how this is fast to run, is self-service, safe, and forgiving. And I'm going to run into this computer here for the sake of demonstration. So I have those 2 windows here. So like here I'm going to start, and I'm going to create my CRL. CRL is now running. And I'm going to now create a word, so create like the event that I created here. This one will take like 30 seconds. But while you like wait here, put this back, and you're like launching the event at this moment. And if we go back here, yeah, it's running. So it tells me there's like a create an event called test, and it put on my local machine because I'm running on my local machine. And here you can see the login. And I also printed a password. So please don't take a picture of that because that's my real password. I'm going to copy this link. And I'm going to paste it here. Oh, yes. I'm running like, don't do that at home if you don't. Yeah, I have to do this because I don't have like a certificate for the page. But then like, yeah, I trust myself. And then I have my word here running. So welcome to test. I can register here, So, or I can log in. So I have like, this is the password that I showed before, and I submit. And now I have my challenge here that I create. So this was just created on my machine. I have like some challenges. So these are the set of exercises I use on our hacking club for our new students that join. So I have some crypto exercises, some Pound exercises, some reverse engineering, some web exercises for us to test. Of course, I'm logged as an administrator. So then I have my admin panel here that can have a bit more information. But let's log out and register a new student. Because let's see, I also have this one available for you online. I'm going to give you the link in a second. So if you want to try later, let's create a new user here. Username, Alice, because Alice, when you work on computer security, everyone is Alice or Bob. And the email could be, I don't know, alice@cal. There's no verification for that, so as long as you have alice@cal, my password will be 123456. And my registration code is one that, like, you need to have that, but it's like 1137. 1337 is a classic computer security thing. It's like a magic number because it reads lit. So that's like a why we talk lit speak. 1337. Submit. Not now. So now I'm Alice, and I'm logging on my exercises. And let's try one of them, or maybe two. Let's see how much time I have. Not much, but then let's try one or two. Biscuit Hunter. So you got invited to a job interview. Hope they serve something delicious with the tea. So this is basically it's basically hinting that you should look for a cookie in this page, right? So, and then if you, probably you have all seen like these cookie banners every time that you log in on a website. Say like, do you accept all the cookies or not? And this is an exercise to teach you a bit about how to find cookies on the pages and identify information. So when you have like a web page like this, usually if you're like doing computer security, first thing that you do, you view the page source, because there's always interesting things on the page source, but you can also like inspect the page. Since I'm going for looking for cookies, I'm going to inspect the page. I like a lot of information here on this console. One that I'm particularly interested in is the storage, because that's where the cookies are located. And I have my cookies, and there's a flag here that is like the, copy this value. So I have the flag, and basically what a cybersecurity exercise is. We look for flags hidden on servers and applications and tools that you have. And I can have to my test, and I can paste my flag here to remove this. And I can submit. Yay, I got it correct. So I can like review this challenge, it's correct. I submit, very good. And we can continue like this. So like, for instance, submit, thank you for rating, good. So then I can go to my other exercise. Oh, this is like cleanup site. I can go to this, open a new one. And it's like a new exercise for me to try. So explore this website, learn more about the services, be sure to check every quarter. So I can start doing that and find a new flag and so on for all the exercises I have behind. This is basically the structure. Let's stop this. So I can purge, it stops, and then like starts to like stopping all the exercise that I have here. And it eventually stop in a second. This is basically the structure that we use for our cybersecurity course. Or cybersecurity, by the way, if you want to actually test it yourself, this is the QR code of this exercise. I can give you the page later. And the registration code is like 1337. So that's like the number that you need for this registration code. You can create any username. Doesn't need to be your email address, doesn't matter. And the course that we gave to our students, this is the structure it has. So it has like 13 exercises, and you start off alpha and goes all the way to mic. And when like every exercise gets a number of points, And for the structure, then they have like hints that people can take, that students can take to help them during their studies. Yes. So that's the demo. So this is the registration code you have on the slide here also, like here on the bottom. So if you want to try that one. But I was talking about like the course, the one that I just showed to you, right? So how had you run that one? So what happened in practice? How should you turn that into actionable, an actionable event? So like for the past 4 years, I've been running an ethical hacking course in the Chaos University. This is like our last run from January to April, so ended like a month ago. And the scale was like that. You have our 70 students, and we ran all of that in 7 old PCs. And for the students, it took like 1-2 minutes to reset. So it's used in a real university course, not only ours, but also the university in Gothenburg was like one of the largest technical universities. They also run the same. They run the same environment that you developed. And a really little maintenance support, basically zero, that like or like a support team has. And everything is also open source. By the way, like here, I can show you the old pieces that you used to run this course. Here it is. So you can tell how old they are if you look at this image. And do you recognize this port here? Yeah, what port is this one? It's VGA. It's an old VGA port. Do computers come with those still? They don't come with those, right? So also you can recognize the serial ports for like a keyboard and mouse that you don't have anymore. So that we took like basically what things that people are throwing away, and we run a course on top of this. So I can recognize here. Also, we have like our swarms here from 1 to 7. One of them is just a controller machine, but the other like run for the support for the students. I also said that it's an open source environment. And here's like the page, like our open source page. You can just download your CyberEngine Lite, run here or run your own PC if you want. And if you want some exercises for that, we have like a set of public challenges that can just download and test. You test yourself. This is the main page that you have like everything. So the idea here is that like we have the CyberEngine as an open source project. We have the public challenges also as open source. But the part that you don't want to open source, of course, are the challenges themselves, because this is what you're going to give the students to practice. Okay, that's the part we're going to give the students to try, right, to run our courses. So this part is the one that is closed, but is open for teachers. So the teachers, let's say, from Stockholm University, or like or Technical University in Stockholm, or Technical University in Gothenburg, they have access, or just the two largest universities, or two of the largest universities in Sweden. That's the ones that they have access to together with us. Also, of course, like here, if people want to have access, you want to run your course, we'll give you access to this. But that's like on request access, right? You don't have it open for the students to find out what the solutions for the exercises are. Where is my, here. It's, as I said, open source, and that's like, you can get everything for the CRL Git repository. All the links here, they are like on the PDF file, so you can have them later. What lessons have we learned so far from this? So one thing that's very important is design of the challenges. So if you can create like challenges that matter, that make sense, this actually is as important as the infrastructure behind. So CRL is just this orchestration tool on bottom of that. But if you don't have like a good exercise design, then there's not much value on just having an orchestration tool. So this challenge is something that where like most of the brains we're going to need in the future are. So that's why like you want to expand this type of like network around it, because the more challenge you have, the more variety you have on the future. The simplicity matters for us teachers. Therefore, we invest a lot of time trying to create like ways for you to develop this infrastructure in a simple way possible for you as a teacher to create a course. Not only for the students that are going to use this. And also, like, depending on the size of the course, the way that you teach the course changes. I started the first year with 24 students. Now I have 70. So that means that when you want to have this flipped classroom type of setting, when like you give the students a lot to do at home, and when they bring, you try to discuss solutions, it means that more people actually it doesn't scale linearly. It's like it doesn't, yeah, we have to be careful of that. Anyway, but what's the, since there is a research day or science day, so what's the research value of a tool that's only used for education or used mainly for education? It's not just like you have to see CRL not only as a training platform, but also help us investigate how actually hands-on security is also taught and learned by students. So what are the impressions that they have from this? So what is it actually gives to them? And for that, you can also like have like published academic papers on top of CRL. So CRL was like you published a paper, like the core course also like how actually structure it was also like some publication that I have. And our courses, they all have like course evaluations on the end. You can also take a look what like our students thought about like how those courses were taught. So for instance, yes, there's some quotes from students that, yeah, this course was valuable in the way that it pushes me as a person. It's like this course you have to adopt yourself, your abilities, maybe even like the point of question that they will be able to graduate at all. But it's, yeah, I've grown so much as a student, and it's like one of my favorite courses of my education. Like this course was without a favorite course that I have learned, that I have taken. So it's a popular course, and the students like to be challenged. So, and then it also makes them to do a lot by themselves. So if you look ahead, what's in our future? There are a few questions that you're like trying to solve right now, like a bit of better oversight and accountability of your tool. Also think about like over-reliance and automation bias when the students face these type of applications. When I have a system that can offer them like hints and directions, how much they get over-reliant on those. So there's something, is also space for like some more research on top of this. The exercise library is still limited, so or it evolves very slowly at this moment. But then try to change that in the future. In terms of collaboration, if you like recall to the first 15 minutes of the day, we have your vice rector of research, Professor Samelka. Yes, there you are. Yes, sorry. You mentioned that you need to cooperate more, and this nowadays, what we have done is within Sweden, we have like a strong network around cybersecurity that like cooperating around this, especially on the developing new cyber challenges, or like distributing this infrastructure. But then like I also like to check mark the EONIS box. So like if you have computer science education, I know that most of you have, then it's something that we're open to collaborate. So that's like as a call for collaboration here. And as a closing thought, if security must be practiced, then the training environment matters. TRL here it will help us to make this practice realistic, scalable, and accessible. And therefore, like to make this as an invitation or open invitation for all of us to collaborate more in the future. Yeah, thank you very much. And like
Thank you very much for your talk, for your presentation. And would anyone like to ask a question?
You can talk to me later also.
Must be a question from the audience. Yes.
I called you, sorry for that.
In the city of Poznań, we have, you know, we can say a family of quantum computers. So can we combine it somehow to the system which you promote?
Do you have API access to your quantum computers?
We have our own, which is up there, and we have 3 more in a supercomputing center. So maybe an idea how we could cooperate, including quantum computers.
Yeah, with post-quantum cryptography, that's like the low-hanging fruit here. So we can like create some exercise. I know that it's a 5 qubit, and I know how fast it is going, but it's the beginning, yes. But thank you.
Thank you once again, Professor Leonardo Martucci. Ladies and gentlemen, the final presentation brings today's event to a close. Thank you very much for the time we have spent together and for your unwavering attention throughout today's event. Now I have the pleasure of giving the floor to a person for whom science and its development are our everyday mission. Let me invite the stage is ready on the stage, the originator of today's event, the driving force behind the idea, Vice Rector for Research at Poznań University of Technology, Professor Wojciech Sumelka.
So, ladies and gentlemen, so first of all, we know who is the strongest one at our university, so congratulations. Probably as you know, such event, there is a need few months to prepare all these little things. So let me thank the people which are just on the screen, because without them it would be impossible to organize such event. So I'm talking here about all deans or directors or chief of divisions, because their task was to prepare a report which you have in printed version and in online version. There is a special web page. There was a poster session, workshops, and of course the whole IT team, which is all the time together with us. So thank you very much. Also promotion and all other persons, and especially our speaker. Thank you very much. So maybe let us thank the whole team one more time. And there is a slogan in science, publish or perish. I guess that we all hate this slogan. I think that starting from today, we can say cooperate or perish. So I hope that it could be really a new slogan. And I believe that, our distinguished guests, which are together with us, and you provided brilliant lectures for us. And I really believe that it's a first and very strong point for a deeper and closer cooperation. Thank you very much, and see you next time. Yeah.